Bit screechy. Hello. Yep, still toner. Quick sanity check. Sanity check. Yep, all looks good. Cool. So let's not waste any time. So tonight we missed this session last week because, well, one reason or another. It's not important now, but now we're going to be finishing off the last Go tutorial. In terms of finishing off this video, might come back to this Go programming course at some point if we're sort of like struggling. But the idea after this is go to Melky's video we put in here, IT manager, and just double check. What do we want to do next off of that? Scott Blueprint. What did he mention? I should have made some notes somewhere. No, I should have made a note. I think I need to have a think about like how I'm organizing notes in Obsidian, because I'm following the para method, and it's good, but there's just like one thing that kind of frustrates me by a little bit, is that there's no kind of natural place for just general notes to exist. They either exist, I suppose that's the point of it really, but like there's just notes that are like connected to, that are not like full resources on themselves. They're like part of like a resource. Might have to think about it. Yeah, I suppose they could be a resource note, couldn't they? I think it needs some like maps of content in here so you can like navigate around a little bit easier. But hold on, let's put a new resource. Um,
manager's dream. No, not that dream. That dream.
Alright, today we're going to learn some Go. Every time I stream myself writing, everyone should recommend this as the very first thing you go if I were to tour of Go. Everyone should recommend this as the very first thing you go if you want to learn Go. It goes through basics, it goes through maybe some more intermediate. You can see here, recommend is Go by example. Go by interfaces, concurrency patterns. If you are serious about Go and you've looked at Go, this
on the tours,
your next stop. This is called Effective Go. This of Effective Go, think like a Golang developer and really adopt the execute the defer and how structs really encompass the data pattern of
Effective Go. Effective Go. Might do, I might not do that one.
Access to the value components that subscribers. Thank you guys so much for your support. But I mind, and they're both by Alex Edwards, and they're actually both part of the same system in web applications in Go. If anyone has done and read these textbooks, they will only say good things about them. This was one of the core textbooks I applications.
Let's go. Let's go.
There's two that can go. It's good to into for text talks from one of the creators, Rob, and I realized these talks and how resource.
I think the other thing to do is the thing to go after was boot dev. But okay. Make a note of those. Okay, that'll do. Now let's get back to what we're meant to be doing. So we're going to finish off this tutorial. Then
That client review was brutal.
we're gonna be underwater for weeks.
We can print
And then that'll be it for this stream. Yeah, I don't think we'll get through it all though, because I don't want to stay on. Yeah. It's 1 hour and 40 minutes. Let's go. See how far we get into it.
Step 1. Now, this is a conditional statement, and it's basically saying if step is equal to 1, then do whatever inside of these brackets. So if step were 2 in this case, if we were passing in 2 as an argument, this code wouldn't execute, because this code in these brackets of this conditional statement will only execute if step is equal to 1. And you might be confused about us using 2 equal signs here. So 2 equal signs means equals, like it means the condition equals. And that's because we use 1 equal sign to assign a value to a variable, right? And that's like built into the programming language. Like, so if we were to try and use 1 equal sign here, Go might think that we're trying to assign the value 1 to step, but like you don't actually need to understand in detail why we use 2 equal signs as opposed to 1. Just know that 2 equal signs means equals to. And for example, less than is less than. So if step is less than 1, then the code in this block executes. And the same thing with less than or equal to, or greater than or equal to, or just greater than. But anyways, here we want to know if step is equal to 1. If step is equal to 1, then execute this code. So this is called a conditional statement. And so we have something that we'll do if step is equal to 1, but what if step is equal to 2, 3, and 4? Well, here we would add else if, and then another condition. So else if step is equal to 2, and then another set of brackets. So else if step is equal to 2, we do what we put inside of these 2 brackets. So we can take this and do that. So if step is equal to 2, we'll print step 2. And we do the same thing for 3 and 4. So we'll do else if step equals 3, we'll print step 3. And then else if step equals 4, we'll print step 4. So this is one way we control the flow of the application. Like we can do different things depending on different conditions, right? So if step is 1, step 1 will get printed, but step 2, 3, and 4 will never get printed because we'll never satisfy this condition, step equals 2, step equals 3, step equals 4, because step is equal to 1, right? So it'll print this, and then all of this gets skipped, and then the function will end. Now, what if step is equal to something other than 1, 2, 3, 4? Well, we can add at the end here just else, and then the brackets here, and we can just print step not supported. So this means that we have a condition for 1, 2, 3, and 4, but anything other than that, else if anything else essentially, then we're just going to say that step isn't supported. So let's actually go ahead and test this out. So if we go back to hello.go, we're setting step equal to 1, and then we're passing step into my function. And my function takes the argument step because it has this step integer parameter, and it checks to see if step is equal to 1. And if step is equal to 1, it will print this. It won't reach these else conditions if step is equal to 1. So let's go ahead and try that out. So we can open our terminal here. And remember, we already have this code inside of our main function. So it's going to run. It's going to set the variable step equal to 1. And then it's going to pass step to my function and call my function. So as you can see here, we're still invoking the function or calling the function using parentheses. But if there are arguments required for the function, we just put the arguments inside of the parentheses. So it should mirror what we have here. So if we go back to hello.go, and then let's just do go run hello.go, you see that step 1 gets printed, but nothing else gets printed because this condition was met. but these other conditions were not met, right? So let's try changing the step, right? Let's change this to let's just do step 4. Let's change it to step 4. So now we're assigning the value 4 to this variable step, and we're passing that variable into my function. And if we do go run hello.go, you see that step 4 gets printed because we didn't meet this condition. So then it checked for this condition. We didn't meet that condition. So then it checked for this condition. We didn't meet that condition. So then it checked for this condition, and we did meet that condition. So it printed step 4. Now let's do one more here. What if we change this to 10? I'm sure you can guess what's going to happen here. So let's just clear this and do go run hello.go. And you can see we print step not supported because in our function, we don't have support for step 10. It only goes up to 4. So if anything beyond that is passed, then we're just going to say step is not supported. So in this function definition, we added a parameter called step. So the caller of the function needs to pass an argument of step, which is, in this case, we're passing in the value 10 as step. And it's the same thing that's happening here in this print line function that we imported when we imported the format package. Print line expects an argument. So we're passing an argument to print line, and it prints whatever we pass it. Now, let's go back to hello.go and continue with trying to understand what types are. So the basic types that you need to understand right now for Go are int, which you just learned about. Int is a number essentially. So if we were to create another int and we were to call it left, and then we create another one and we call it right, and we'll change left to 5 and right is 10, and we'll once again use print line from the format package. If we were to print left plus right, since these are both numbers, left plus right is going to add these two numbers together and print them. So for now, let's delete this step and let's delete the call to the test package to avoid confusion. So if we run this, you see that 15 gets printed because we assigned the variable left this value 5 and we gave the variable right this value 10. So when we do left plus right, we get the sum of those two values. And we can do the same thing with subtraction or any other arithmetic, for example. So let's run it with subtraction. And you see we get -5 because 5 minus 10 is -5. So that is the int type, the basic type int. Another type that we're going to be making use of is the string type. So we'll say var name and we'll call it string and we'll set it equal to James. So here, if we print name, let's delete this left. If we print name, it's going to print this value James. And as you can see here, it prints James. Now this is a string value, and a string value is just a string of characters. And you can recognize a string by the use of these quotations here. For example, if we try to put an integer here, we're going to get an error because this isn't a string, this is an integer. But if we were to add these quotation marks here, it becomes a string. So if we were to create left, right, and print left plus right here, what's going to happen is probably unexpected to you as a beginner. Like you would think maybe it's going to add them together and it'll be 22, right? But it's not because it's not an integer. So you can't do arithmetic on it. So it's a string of characters. So when we add them together, we'll do go run hello.go. We get 1210 because what it's doing is it's just concatenating the characters, and concatenating just means it's just doing this. It's just merging them together to a longer string of characters. Like you can't see the parentheses here, but when it's being printed to the terminal, it's actually printing a string and not an integer. And let me use a different example to kind of exemplify what I'm saying here. So if we put James here and put Smith here, and we select the terminal and go run hello.go, you see that it just concatenates James and Smith and makes it into one string, James Smith. And strings can also include spaces. So if we put a space here, that's a character as well. Space is a character as well. So it'll be James space Smith when we add them together. So if we go run hello.go, you see now it's James Smith with a space. Now I encourage you to go and mess around with these types to kind of see how they work. That's a general explanation of a string and an integer. So remember, integers, we can use arithmetic on them, but remember for strings, if we add them together, it's just going to concatenate them. So what do you think might happen if we try to subtract them? Well, we get an error because we can't do arithmetic on strings because they're not integers, they're not numbers. So it says invalid operation left minus right. The operator is not defined on string. And this just means, of course, we can't subtract a string from a string because they're not integers.
Halftime speak because I want to get through.
One more type that we need to take into consideration is, we'll do is happy, and we'll change this to bool. And a bool is just true or false. So let's delete these, and we can change in here to is happy. So when we do go run hello.go, you see true is going to get printed to the screen. Now, if we change this to false, and we do go run hello.go, you see false gets printed to the screen. And you might be wondering, how are these bool variables useful? And to that, I say you don't need to know how the bool variable is useful yet because we're not making use of it yet. So don't worry about why it's useful yet. You just need to know that there is a data type called bool, which is true or false, and we can assign that to a variable. So yeah, just keep in mind that we have these three data types. And don't worry about these variable names. I just wrote anything just to show these three data types. So remember, we have a bool, which is true or false. We have a string, which is a string of characters. And we have an integer, which is an integer, a number. So let's go ahead and delete that. So now at this point, you should have an understanding of function parameters and their types. So let me just explain a little bit more about this function parameter. So like the type has to be an int. It's required to be an int if you call this function. If you try to pass in a string, it's not going to work because this function only accepts an int. So if we go and we do test package my function and we pass in this is a string, you see that it's red here. It's not going to work. So it says cannot use this is a string type string as type int, of course, because it accepts only a type int. And if we go to my function and we change this to string, it's still going to break because now we're trying to compare a string to an integer, and you can't compare the two because they're not the same type. So if we changed these numbers here to string, then we could compare them. Like you see the error goes away for this one, but these ones are still wrong. We're comparing a string to an integer. And yeah, I hope you understand what I'm saying with that. But if you're not fully grasping this, if you grasp most of it, but you're still not fully grasping it, it's fine to continue on with the video because things will become more clear as we actually use these things to build what we're building. But if you completely don't understand what I'm talking about here, I encourage you to rewind the video and go back and go over these fundamentals again because they're necessary. You need to be able to understand these things to be able to continue with the rest of the tutorial. Now, as we continue with the tutorial, I'll introduce new things as we're building our backend, and everything that I introduce, I'll explain it. So yeah, I think it's okay for us to move on at this point. So you should understand the following things at this point. You should understand what a function is, and you should understand how to export a function using the capital letter when you name the function. You should understand what a package is, and you should understand how to import a package and call a package's function. And you should understand function parameters and how we can use them to make our functions more configurable or customizable by the caller. You should understand what a private function is, and you should understand that private functions can only be used within the package that they're defined. So we actually didn't go over that part. So a private function, since it's not exported, since we're not using a capital letter here, it means that it can only be used inside of the package where it's defined. So this private function is defined in this test package. So for example, in my function, we could call my private function. And you can see we don't have to prefix this with the name of the package because we're calling the function from within the package. So inside here, we can call my private function. But in our main package or our entry point, we can't call my private function because let's delete that. If we do test package my private function, you see that we get the error here, unexported function, my private function. And you also see here that we have to prefix the function name with the package when we're calling it from a package that's not the package where the function is actually defined. So that's what you need to know about that. And you also need to know about the main function. Like you need to know about how the main function is the entry point to the application, and how the main package is the package where the entry point is defined. And I already told you how you can imagine that this main package is being imported by Go behind the scenes. And you should also have an understanding of types, more specifically the basic types, string, bool, and integer. And you should have understanding with variables and how we actually define variables by naming them and putting the type, and then putting a value for the variable. So yeah, that's everything that you need to understand up until this point. If any of these things are confusing to you or you don't grasp them at least like 80%, then I suggest that you go back and rewatch the part of the video where I explain these things, because these are basically the prerequisites that you need to understand in order to actually build this API that we're going to build. And like I said, whatever new things that I introduce, I'll explain them as I introduce them. But those are just the fundamentals. That's the baseline understanding that you need to have in order to move forward. So yeah, if you've made it up until this point, we are going to now start to actually build the API that's going to be called by the front end that we spun up earlier, or the pre-built front end that we downloaded and started up earlier, which is the product page. So we're now building the application programming interface that's going to run on the backend server that the front end code is going to call. And if you don't know what I mean by that, you should go back and rewatch the part where I explain the key terms prior to explaining the fundamental things that you need to be able to code the project. So yeah, from here, we can make our main function vanilla. Like we can remove everything from it and just have our main package with the main function with no code in it yet. So right now, this is just an empty application, but it contains the minimum requirements for a Go application. So like explained before, the Go application, you need to have this package main and you need to have the entry point. So you can actually run this right now. Go run hello.go. Nothing happens, but it actually called this function, but there's nothing in the function. So that's why nothing shows up here. So we'll have this minimum requirement, which is main.go. And then this package, we actually don't need this package. This was just an example. I just wanted to show you what a package is. So you can close that package folder and just delete the whole folder. And it'll ask if you want to delete the directory test package, just delete it. And we can just change the name of this back to main.go. And now you should have a completely empty Go application, the file main.go. And that's just in the Go tutorial folder, the project folder. So the next thing that we need to do is we need to start building our actual backend API. So in order to do that, like I explained before, we're going to use a payment processing platform called Stripe. So the code that we're going to be writing here is going to make heavy use of that payment processing platform. And you'll understand what I mean by that soon. But first, we need to make sure we create a Stripe account so that we can make use of it. So you can go ahead and open up a browser and you can just type in Stripe payment. And you can just go ahead and select this first one here and then select Start Now. And here you will create your account. Now, I already have an account. So once you've finished creating your account, you can go ahead and sign into your account. Now, once you've created and set up your account and you've logged in, you should be taken to this dashboard.stripe.com. And it should be /test dashboard. If you're not on the test dashboard, then just put /test dashboard in the URL and hit enter. And you'll be brought to this test dashboard. Now, the first thing that we want to do as soon as we access this dashboard is we need to look down here to the right side and see if you have these publishable key and secret keys. And you're going to copy this publishable key, copy the publishable key, click it and copy it to your clipboard, and then go and open up your terminal. And from your terminal, you want to change directory to that front end that we downloaded before, Go for Beginners front end. And then you should change directory to the folder called src. And then you can ls here, and there's a file here called stripepayment.jsx. I want you to open this file with a text editor that should be already pre-installed on your system if you're using Mac, and it's called Nano. So you'll type nano stripepayment.jsx and then press enter. So this should open the file like so. And you should be able to use the arrow keys on your keyboard to go down, down, down all the way until you get to this string here that has this long key in it, pktest51n9, blah, blah, blah. And I want you to go all the way to the end here, all the way till you get to the end quote. And once you get to the end quote here, I just want you to hit backspace and delete everything inside of the quotation marks. And then you should be able to paste in that key that you copied from the actual dashboard of your account. And when you paste it in, it might mess up the spacing. So just go all the way back to the beginning of the key, to the beginning quote, and then hit tab and then backspace twice. And after that, you want to type in Control X, and it's going to say here, save modified buffer. Answering no will destroy changes. You want to type the letter Y to save the changes that we just made. So just type Y, and then it'll say file name to write, and we still want to keep the same file name, so you can just hit enter, and that should save the file. And after that, you can just go ahead and close your terminal. But yeah, it's very important that you change that key inside of that file. So make sure you do that and confirm that you have the proper key that's from your dashboard stored in that file. And I can't stress it enough, not having the proper key there will break the application for you. Like, you won't be able to complete the tutorial. So make sure you confirm that it's the proper key. But anyways, now that we have a Stripe account, we can start writing our backend code, and our backend code is going to make use of that Stripe account. So if you recall, our backend code is the server code that provides an interface for our front end to use to communicate. So our front end is going to need to be able to send requests to our backend server. And this is the code that's going to handle those requests. So that request is going to be sent over the internet. So the front end is going to send a request to our backend server over the internet. And that request is called an HTTP request. So we're actually going to need to import one of Go's packages from its standard library that helps us to handle these types of requests coming from front-end clients. So let's just start off by writing out some imports. Now in Go, before you saw that we were importing single packages like this with quotation marks, right? But in Go, you can actually import a list of packages. So instead of doing import name of package, we can just import all of them in the same list. So let me show you what I mean. So we want to import the package called net/HTTP. And remember, this is a package provided by the Go programming language, and we can use this to handle requests sent from the front end to our backend server. But we're also going to want to import format again, just for our testing purposes. Now, instead of using the import keyword twice, we can just use it once. We can just do it like this. So using these parentheses, we're able to import multiple packages at once. But don't get these parentheses confused with the parentheses that we use when we create and invoke functions. They're not the same thing. This is a completely separate thing. This is just us importing multiple packages using the same import keyword instead of listing import multiple times. So like I said, we need to be able to accept the HTTP requests from our front end. So we need to provide the interface for the front end to be able to send these requests. And the way that we do that in Go is we'll use this HTTP packages function called handlefunc. And this function is going to take 2 arguments. And this leads us to something that we're actually going to need to familiarize ourselves with in this Golang IDE. So as we discussed before, these packages provide functions for us to use, right? So we're using this HTTP packages function called handlefunc. But there are cases where we're going to want to know more information about the function and how to use it. So in that case, in Golang, you can just hover over the function and it'll give you all of this additional information about the function. So as you can see up here, handlefunc takes the parameter pattern and the parameter handler. And it tells you that this pattern parameter is a string and this handler parameter is actually a function. And this function actually needs to take response writer and request parameter. And both of these come from the HTTP package. Now, this part is not necessary to understand fully at the moment. So don't worry too much about this part. Just know that this handlefunc takes a pattern, which is a string, and a handler, which is a function. So we're going to need to write a function to pass to this function. And you'll see what I mean by that soon. But first, I need to explain to you what this pattern is. And to do that, I need to explain to you what it means to send a request to a server. So I want you to imagine that this entire screen is the internet. And let's say, for example, we have our server and our front end at different locations in the internet. So here's our server and here's our front end. And maybe this server is hosted in some entirely different country or whatever. The point is, these 2 entities, they're not hosted in the same location or on the same server. So this is the backend server, and this is the front end that needs to call the backend. So how does the front end access the backend server? Maybe the server is hosted in Brazil or something. So how does this front end make a call to a server among many other servers on the internet? Because of course it's the internet, so maybe there are many other servers. So again, we want to target a specific server. We don't want to target any of these other servers. Like maybe this is Google's server, maybe this is like Yahoo's server, and this is the server that we want to target for our front end, right? So how does our front end access this server? Well, it's similar to the way you know how to send mail to somebody in the real world. You know their address. And it's the same thing with the internet. In the internet, servers have addresses, and I'm sure you're already familiar with the concept of an IP address. So that's what I'm talking about here. So the way that our front end will access this server is by accessing its associated IP address. So maybe our server's IP address looks like this. So that would mean that our front end can send requests to this IP address. So maybe the front end wants to send a request. It knows the IP address of the server that it needs to send the request to, so it can send the request to that IP address. Now, just because our front end has the IP address to the server doesn't mean that the front end can actually interface with our server, because on the server's operating system, there are actually these numbers called ports. And these ports are basically at the OS level. So you don't need to know about that. Just know that the server's operating system will have ports that are used for network connections. Like a server may or may not have ports open for receiving internet traffic from another location. But in our case, you don't need to think about any of that stuff. We're just going to imagine that we do have a port that our front end can use. And the range available for ports is actually 0 to 65,353. Now, there are some ports that are reserved and some ports that we shouldn't use and stuff like that, etc. But again, for this tutorial, you don't need to know that much detail about this. Just know that on the operating system level, the server is going to have a range of ports available, and each port can be used to connect to the server if the server allows it, essentially. So when the front end uses the IP address to call our server, it also needs to provide a port. So what that's going to look like is this. So the front end will send the request. So this is the request to our server's IP address. including the port. And in our case, we're using port 4242. So now our front end can send a request to our server using the IP address and a specific port. So that port's going to allow our front end to essentially connect to our server, because the port on the operating system level is used for the connection. If there's no port to use, then sending a request to just the IP address would be useless. So in our backend code, we're actually going to listen on this port. So any request that comes into this IP address on this port will get picked up by our server, because in the code, we're actually going to listen on port 4242. But we have another issue here. So like if the front end sends a request to our server, how does our server know what the front end wants us to do? The front end essentially sends us a request to do something, right? And the backend code needs to have some way of knowing what the front end wants us to do, right? And if the front end is just sending a request to our IP address on our port that we're listening on, I mean, we get the request, but we don't know what the front end wants us to do with that request. So that's why we need to provide the interface for the front end to use. So the way that we do that is we provide API endpoints. Essentially, it's like a path to a specific functionality. So in our case, our server, let's just do some bubbles here, is going to provide an endpoint called create payment intent. And this endpoint is going to map to some functionality on our server. So when we receive a request to this endpoint specifically, we're going to trigger some code that creates the payment intent, does exactly what this says. So that means that our front end is only able to ask us to create payment intent if we only have this endpoint. If the front end needs additional functionality, they need to ask us to build that or add additional endpoints to support that additional functionality. But in the beginning, in this tutorial, the endpoint is create payment intent. So the front end is going to send us a request to create the payment intent. And that's going to trigger a function on our code that will actually create the payment intent on the back end. So you're probably wondering, when the front end sends this request, how do they specify a particular endpoint? In this example, create payment intent. Well, they just append this endpoint to the address when they're sending the request. So it would look like this. So instead of just having the IP address and the port, we'd also add this part to the end. So then when the front end sends the request to our IP address at our port that we're listening on, specifying that it wants to create a payment intent, then in our code, we know what functionality we need to trigger. And we're going to be building this or writing the code for this in Go. So exactly what I'm explaining here right now, having this endpoint mapped to some functionality in our code, when the front end sends a request to that endpoint, that's what we're going to be building here. Now, this is a very simple explanation of how this stuff works. You can dive deeper into like networking stuff and how domain names and IP addresses are resolved and stuff like that. But for the purposes of this tutorial, I don't want to go too deep into networking stuff because it'll just cause confusion when you're trying to focus on learning the programming language. You really only need to know these surface level details to understand how a front end sends a request to an API and how that request is mapped to some specific functionality on the backend server. Okay, so now that you have an understanding of what it means to actually send a request to a server and how the URL is essentially the address for that server, the pattern that's expected for this handle func is actually just the pattern at the end of the URL. So for example, when the front end sends a request to our server, it's going to send the request to the address where our server is hosted, right? And since we're building the application, we're hosting the server on our local machine and we're using port 4242. But that's the base URL, like that's the address for our entire server. But the interface that we provide to the front end needs a specific endpoint. Like we want to essentially assign different URL paths to different functionality. For example, the first functionality that we need to provide to the front end is going to be called create payment intent. So whenever the front end needs to initialize a payment, so that's essentially when the user reaches the checkout page, the front end is going to need to create a payment intent for that user. Or a better way of explaining it is the front end is going to need us to create the payment intent for the user. So the way that the front end asks us to do that is they send a request to a specific endpoint. So for example, we might have many different types of endpoints. So a usual endpoint is like a health endpoint. And this just checks to see if the server is up. Like the front end has no way of knowing if our server is running, right? Because they're calling us from a different location or a remote location. So maybe they just want to check and see if the server is up. They can send a request to this health endpoint and we'd need to provide that functionality to them. So for example, here, we're going to provide the functionality to create payment intent, and there should be a / here. And in order to provide this functionality to them, we need to give them the actual endpoint to call. So in this case, they'll call the create payment intent endpoint. So it would look like this. So this is the address the front end would send the request to create a payment intent. And if we wanted to give them the health functionality as well, we'd need to create an endpoint for that as well. So now at this point, we're providing the front end with the interface to actually trigger our code. But you're probably wondering, so where do we write our code? We're just giving them this address or this endpoint, but there's no functionality triggered by any of this. Well, that's where this handle func function comes in. So if you see here, it says handle func registers the handler function for the given pattern. So that means that handle func is going to register the function that we create, and it's going to essentially map it to the given pattern. So when the front end calls this endpoint or pattern, we're going to have a function that gets triggered, and that function is going to be called handle create payment intent. Now you can see this is red here, right? And it's red here because we haven't created this function. So we need to create this function. So we can go down under main and we'll do func handle create payment intent. And remember, this function needs to take in two things. So if we go back to our handle func documentation here, you see that the function they expect, the handler is the function they expect to be passed to this handle func as an argument. And it's saying the function has to take in a response writer and a pointer to a request. This star means pointer, but you don't need to know what a pointer is yet. Just know that it needs to take in response writer and request. Now this response writer and request comes from this HTTP package. They're types provided by the HTTP package. Now remember the types that we went over: string, bool, and int. Well, in Go, you can actually create your own types as well. And this HTTP package created the response writer type and request type for us, and we can use these types. So when we create our function parameters, we can say W, that's what we're going to name the response writer. And we can just, from the HTTP package, use the response writer type, this type here. And if we hover over this, you can see where they're creating this type using the type keyword response writer. And you don't need to know all of this stuff yet. Just know that this is a type that was created by the HTTP package, and we need to accept that into the function that we use here. Now, I know it sounds confusing, but just bear with me, things will become more clear. So remember, we need to pass the response writer and a pointer to request. So for request, we'll just call it R, and the type that we need to use is pointer to http.request. So now we've met the minimum conditions with this function to pass it to handle func, right? So now we can just finish writing this function. And we can comment this out for now. And I haven't explained to you what it means to comment out code, so let me explain it now. So just now, I added these 2 forward slashes to the beginning of this line of code. That makes the code commented out. Like, when you run the program, this code won't be executed. It'll be ignored. So for example, if I comment this one out, it'll be ignored as well. So when we run func main, nothing will happen because both of the lines of code have been commented out. But if you remove those forward slashes, they become active. Like this line of code will execute when we run main. Now I just wanted to comment out this health one right now because I just want to show you how handle func actually works. And also let me collapse this. So you can collapse this side thing by just selecting project. And I'm just collapsing it so you guys can see all of the code here. Now you understand that in order for the front end to call our back end, they need to use this address. Or if we implement this health one down here, this address. But right now we haven't implemented this or provided this to them. We're just doing this one for now. So remember, the handle func basically registers the function that's going to be called whenever the front end calls this endpoint. So the endpoint is just the path after the address of the server. So the front end calls this endpoint, this function gets triggered. So that means that if we do format.println here and we just type endpoint called, whenever a request is sent to this endpoint called is going to get printed to the screen. Now we'll get to that in a second. So we need to actually remove this here. This was just to explain, but we can't have that there because the code won't work in that case. And you might see these green lines under our imports here. And if you hover over it, you see that it says imports are not sorted. And that's just because our imports aren't in alphabetical order. So what we can do is Go has its own formatter that like organizes your code for you. So if we hit project again and we right click our main.go file, you can just go ahead and select reformat code. And then it'll say optimize imports, make sure that box is checked, clean up code, make sure that box is checked, and then you just hit OK. And as you can see, it reorganized the import so that they're in alphabetical order. So whenever you wrote some code, just go ahead and get in the habit of formatting it using this reformat code tool. But let's minimize that again. And we're not going to add the health endpoint yet because I just want to show you guys how this endpoint is working, like how it's going to trigger this function. Now, right now, we have the endpoint mapped to a function, right? But we don't have any code that's telling this file that it's going to be a running server. Like if you recall, last time we were running our Go file, this func main would execute all of the code inside of it, and then it would just be done after that, right? But for a server, for an API, for server code, we need what's called a long-living application. Like the application needs to run continuously because it needs to always be listening to these requests coming in from the front end, right? So that means that it always needs to be running. So servers need to always be running. Active servers always need to be running. So we can't have it finish this main and then stop running. We need it to run continuously. And this HTTP package provides that functionality for us as well. And it provides that functionality with a function called listen and serve. And this function needs to take in some arguments as well. First of all, it needs to take in the address. And in our case, the address is just going to be localhost and then port 4242. And we can check what else it needs to take if we just hover over this. So we see it needs to take an address, which is a string, and a handler. But we don't need to worry about the handler part. In our case, we're just going to put null for this, or nil in Go. So nil just means nothing, like we're not going to pass anything there. So you can see here, nil is a pre-declared identifier representing the 0 value for a pointer, channel, func, etc. Like whenever you want to know what something is, you can just hover over it and the IDE will explain to you what it is. So we can hover over this HTTP package and it tells you package HTTP provides HTTP client and server implementations. So just get in the habit of trying to read this stuff and understand what's happening here, right? Anyways, so we can hover over listen and serve, and it says listen and serve listens on the TCP network address ADDR, which is the variable, this variable here that it expects, this argument here that it expects. So it listens on that address and then calls serve with the handler to handle requests on incoming connections. So when the front end connects to our address. Depending on which path is appended to the address, like which path comes after 4242, it will trigger whatever handler function is associated with that endpoint. So running this is actually going to run the server. But there's something new here that I need to explain to you. So like this function, as you can see here, it has these two parameters, right? But it also has another type here, right? And that's because this function actually returns a value, but it only returns a value if an error occurs. Now that's a bit confusing to understand, so I have to go ahead and explain that to you right now. So if we create a function here, and we'll just call it returns value. In the beginning, when we were creating functions, we just did it simply like this, and maybe we had like a parameter like something which was a string, right? And when this function gets called, it just executes whatever code is inside of it, and then that's it, right? But actually, functions are capable of returning things back to the caller. And how to do that is after the parenthesis where the function parameters are, you'll put the type of value that gets returned. Now this function is required to return something. So you get this red line here, right? It says missing the return statement at the end of the function. A return statement, you literally just type the return word and you return something. But that something has to be the same type that you're saying gets returned here. So this is where we're saying what type of something gets returned. So if this is int, then it's going to say this is an error. We're returning a string here, but it should be an int, right? But here, let's say it's string. So that means that we can do this. So they can pass in something as a parameter, right? And that parameter is a string, right? We're expecting a string as the argument. So we can just return that back to them. And maybe using something for the argument and the return value is a bit confusing, but I think you'll understand the point. So let me just go ahead and comment out this code here in main, and then we'll just call returns value. We'll call it, and we'll pass in the value that we want to be returned, something. So what do we want to, we'll just put hello. I will return this back to you. So now, since this returns value, actually, when we call it, it's going to return a value. We need to catch that value, right? So we can catch that value by creating a variable, and we can just call it cot value, and it's a string, and we set it equal to the result of this function. So this returns value is going to return this string that we pass into it, right? And we want to catch it and store it in this cot value. And then after that, we can print it. So we'll just print cot value. And I spelled format wrong here. So I think you can guess what's going to happen here, but let's just run it anyway so we can see what happens. So we'll do go run, and we change the name of the file to main.go. So, and as you can see, what gets printed is hello, I will return this back to you. Now this is very important to understand. So it basically combines everything we've learned up until this point, and it also includes returning values from a function. So we're creating this variable here, right? Remember, a variable is a way to assign a name to some value so that we can reference it later. So we're assigning this cot value name to the result of this returns value function. And this returns value function takes in the argument, which is a string, and it just returns that string back to us. And that's represented here. This is telling us the return value of this function is a string. So since when we call this function, it returns this string right back to us, this string just gets put in this box, this cot value box or variable. And then later we can reference that cot value because we named it, right? And then we can print it. And that's how return values work in functions. So let's go ahead and delete this. And let's delete this cot value as well and this print statement. And we'll uncomment this. And now back to the reason I had to explain to you what a return value is. This listen and serve returns a value as well. It returns type error. Remember the type that comes after the parentheses where the parameters are defined in the function definition. That's the type that's being returned from the function. So we need to accept a type error. So here, when we call this function, we need to catch its return value in a variable. And it's the error, so we'll just call it error and its type error. Now, we've reached another important checkpoint in Go. Go, whenever there's an error expected to potentially return from a function. So whenever a Go function returns an error, it doesn't mean that whenever you call the function, an error will be returned. It means that there's a potential for an error to be returned. So it means that it's possible that when this function gets called, an error gets returned, but it might not return an error. So listen and serve, basically, it's going to start our server, our long running or long living application. It's going to run our server and listen to requests coming in. But if there's an error with listen and serve, then it'll return an error. And in that case, as the people writing the code, we need to handle that error. So we need to potentially accept the error. So we're assigning the error to this variable. So if listen and serve returns an error, it's going to be put in this box, in this variable. But we're not doing anything with that variable right now. So even now, with catching this error, if it happens, we're not doing anything with it. So we still wouldn't know if there's an error. So what we need to do is under this var error equals listen and serve, we need to check if that error exists. So we say if error not equal nil. So if error is not nil. So remember I told you what nil is. Nil means it's like an identifier for nothing. So if the error is not nothing, meaning if there is an error, then we need to do whatever is in these brackets here. And in our case, if there's an error, we're going to use Go's log package, another package that we'll import. And then there's a function in that package called fatal. And you can see here that log automatically gets imported by the IDE, and there's a function in that package called fatal. And this fatal function is just going to basically print out what the error is, then it's going to completely exit the application. So we need to pass it the error. And this is how error handling is done in Go. So any function that potentially returns an error, we're going to need to check and see if that error gets returned from the function. And if it is, we're going to need to handle that error in some way. Now, you don't need a deep understanding of this point just yet. Just know that that's a general overview of how error handling is done in Go. So for this particular listen and serve function, what we're doing is we're running the application continuously, and we're just listening for requests coming in. And if there's no error, then we'll never get to this point. But if there is an error, it'll get caught into this variable, and then we'll do whatever code is inside of these brackets. Now, I know that was a lot to understand, so I think we need to solidify this knowledge by actually testing this code out. And I encourage you, if you're following along with this tutorial, to be writing out and testing out everything that I'm explaining here, because it's one thing to just hear me explain something to you, but you're not going to fully grasp and retain the information unless you actually take action and do what I'm doing, like follow along with what I'm doing and practice and mess around with things and tinker. Like, that's how you learn how to code. Like, you don't learn how to code by just listening to somebody talk and explain things to you, because it doesn't matter how detailed I am in explaining these things if you're not actually following along and getting a feel for how this stuff works. So I just want to put that out there, because I don't want you guys to be wasting your time. Like, you really need to follow along and really try to get a feel for these things. So let's go ahead and test this, and we're going to try to solidify your understanding of how to handle HTTP requests in Go, like how to create this API. Like right now, what we're creating is the API that I told you about before, the application programming interface. This API is used by the front end. So let's go ahead and get our hands dirty and try and test this out. So before we can test this out, we have to install a tool, and this tool is going to allow us to act as the front end without actually being the front end. And you'll see what I mean once we install the tool. So what you want to do is you want to just go ahead and open your browser. And just go to Google and search for Postman. And you can just select this first option here, and we're just going to download the desktop app. So I'm using Mac, so I'll select the Mac one, and I have an Apple chip, so I'll use the Apple chip one. Once that's finished installing, you can just go ahead and unzip it. And after you unzip it, you can just move this to the applications folder, and we can just go ahead and open up this application called Postman. And it looks like mine is a bit broken, but I'm just going to hit skip and go to the app, and that looks fine. Anyways, what this tool is going to do is it's going to allow us to send HTTP requests, the request that I explained to you before, to a given address or URL. So what we're going to do is we're just going to put the URL inside of this bar here. And it's hard to see because my app is messing up, but we're going to put the URL into here. And then we're just going to send the request to our server. And our server is actually going to be running on our local machine. So actually, let me just quickly explain to you what I mean by that, because that might be a bit confusing. Now, you should recall from the explanation about the server and us sending the request to the server from the front end, a diagram that looked something like this. So in a real world situation, or a situation where our application is actually deployed to a production server, requests would come in from the front end, wherever it is, to our backend server. Remember, this is the request. But while we're actually developing, as you saw before, we were running our front end on our server. So if we just make this larger and we can move that. So while we're developing, our front end's actually running on our server. And while we're developing, another thing that's running on our server is the server code, which is that's normal for the server code to run on the server, right? But this is what it looks like when we're developing. The front end's running on the server and our server code's running on the server. So when we're testing in development, we want to send a request from the front end that's running on our server to our server code or our API that's running on our server, the Go application. So this is the Go application, which is different from what we'd be doing if this were actually deployed to production. In production, the front end wouldn't be running on our backend server. It would just be running somewhere else, and it would be sending requests over the internet to the server. But while we're developing, it's running on our server. So that means that the address that the front end needs to send requests to is the same address that it's running on. It's the same server, but that's just because we're developing this application on our local machine. In this case, the server is our local machine, but in real life, we wouldn't run a backend server from our local machine. But while we're developing, we use our local machine, your laptop or PC or whatever, to host both the server code and the front-end application, just so you can have an easy development flow. So if you understand that your local machine is actually the server in this case while we're developing, then you also understand that your local machine has an address. Or if you don't understand that, I'm explaining that to you now. So your local machine, it has an address. It has a local IP address, which is an internal IP address. And this IP address is just called localhost. But that's just a name for an actual IP address. Like under the hood, your local machine has an internal IP address that is 127.0.0.1. But this IP address can be referenced by just using the name localhost within your system, because there's actually a file that maps this IP address to the name localhost. So they're actually interchangeable. You can use this IP address or the name localhost as the address if you want to access your local system's internal IP address. So that means that we have this internal IP address, and both our front end and our server are using the same IP address, but they're using different ports. That's why we're able to run both of these on the same system or server or computer because they're running on different ports. So what's essentially going to happen is we're going to run our server, then we're going to run our front end, and our server is going to be running on one port, which is 4242. And our front end is going to run on some other port. But in order for our front end to send requests to our server code, our Go program, it's just going to need to send a request to localhost at this port. So it'll send the request to localhost 4242, and sorry if that's too small, using the endpoint. So that's what this localhost means. And when we run the server, I'll show you a little bit more of what I mean about this, but this is essentially the setup that you'll usually use like for your development flow. When you're developing an application or an API, you'll usually have a setup similar to this. You'll be running everything from your local machine, even the server code. But when you actually deploy to a production server, the code gets put onto another server, like maybe like some AWS server or a Google server or something like that. The actual backend isn't going to run from your local machine. Your local machine isn't powerful enough to handle the type of traffic that hits a typical like web application that has any level of popularity. So this is just how we're developing. We're developing on our local machine, and this is how it's working. So I hope that makes sense. Okay, so I actually ended up needing to install an older version of Postman because the newer version wasn't working for me. It was just broken. So I installed an older one. So if you need to do the same thing, you can just go to Google and type in download older version of Postman. And then I just selected this one and just selected this link provided here. And then I just went down to downloading Postman V8, and I just downloaded the V8 one for 64-bit Mac OS because it's still possible to run it on this M1 Mac using that Rosetta thing, I believe. So yeah, that's the one that I'm using. If the newer version works for you, then you don't need to do this part. But if the newer version's breaking for you like it was for me, then you can go ahead and download an older version. And I'm just going to dismiss this update available because the update doesn't work for me. And yeah, it's pretty much the same thing. Like we need to put the URL or the address to the backend server in this text input here, and then we'll just send the request. So remember, with this, we're emulating the front end. Like we'll be sending the same request that the front end is going to be sending to our backend server. This just gives us an easy way to trigger the request getting sent to the backend to test our backend. So let's go ahead and open Goland up again, and let's just continue where we left off. So before we go ahead and test this endpoint, like the calling of this endpoint using Postman, there are a couple of things that I still want to go over, or I want to elaborate on, some things that we already talked about. So first of all, I want to elaborate a bit more on error handling in Go, because I think there's still some things you might be confused about even after the before explanation. So the first thing I want to elaborate on is this error type. So this error type is a built-in type provided by Go. So just like string and bool and int, Go provides this error type as well. And functions that return errors, they return this error type. So I want to explore that a bit more. So let's just create a function here really quick. So we'll do func returns error. And remember, to return something, we have to put the return type here. So this function is going to return this error type. Now this function either has to return an error or it has to return nil. So for example, if we do return nil, you see that we don't get any errors. And if we do return some string, you see that we do get an error. So it has to either return an error or nil. And we can actually create our own errors using a package from Go standard library called errors. And then we can use a function from that package called new, and we can just say an error occurred. We just pass a string into this function. And as you can see here, we're getting no error because this new function returns an error here. So new returns an error that formats as the given text. So it's basically changing our string into an error. So what we can do is we can go ahead and add a function parameter, which we'll just call password, and it'll be a string. And what we can do is we can have the caller of the function pass in a password. And if the password is correct, we can return nil, so no error. And if the password is incorrect, we can return this error. So we'll just say var secret password string equals super secret password. And then we'll say if password equals secret password, return nil, else return error, invalid password. So what this is doing is we're gonna have the caller pass in some string as a password. And in the function, we're gonna define the actual password, right? So we're defining the actual password. Then here, we're checking to see if the password passed in by the caller of the function here is equal to our secret password. And if it is, if it's equal, then we'll return nil. There's no error, so we'll just return nil. Else, if the password's not equal, we're going to return this error here, invalid password. So if we go back into main, and again, we're just going to comment this out, and we call returns error, and we pass in wrong password. Now, in this case, we're passing the wrong password, so an error is going to be returned by the function, right? But right now, we're not catching this error. So I'm sure you can guess what's going to happen if we run this function then. So if we do go run main.go, you see nothing happens. So an error actually was returned from our function, but we have no way of seeing it. As the person developing this code or as the person debugging this code, we'll have no way of knowing what happened. The application is just not working, but we don't know what's happening because we're not catching the error and we're not handling the error. So in Go, it's your responsibility to handle the errors. So if you're calling a function that's going to return an error, you need to catch the error and you need to catch it in a variable. So we'll do var, and the conventional name, variable name for errors in Go is ERR for error. And then the type is error, and we'll set it equal to returns error, right? And you're gonna see the same pattern a lot. You're just gonna always see the same pattern here. If error not equal nil, then do something. So in this case, we're not gonna do log fatal, we're just going to print the error. So here we're catching the error that gets returned from this returns error function into this variable called error, ERR, which is the conventional name that we use in Go when we catch errors. And then we're checking if that error is nil. Because remember, if there's no error, we'll just return nil, right? If the password is correct, we just return nil. But if the password is incorrect, we return the error. So that means that we need to check if the error is not nil. And if it's not nil, it means the password was incorrect, which means we receive the error. And that's when we're going to print it. So let's go to the terminal here again and do go run main.go. And now you can see invalid password gets printed to the screen because we actually handled the error that time. And we're just printing it to the screen. But in a usual scenario, you'll actually do something to handle the error depending on the functionality of your application. But you don't need to worry about that part right now. Just know that we need to catch and handle the errors. Otherwise, they'll just be hidden from us and we might be writing bugs into our code or something and we have no idea what's going on. So that's what is meant when we're doing if error not equals nil. Even up here for our call to this listen and serve function. Like the function will either actually return nil or return an error. But in the case for the listen and serve function, it's actually a little bit different. So I'll show you what's happening here as well. So first, let's go ahead and delete this, and we can delete this returns error example function, and we can remove the comments from here. Now, the way listen and serve works, like the way the error handling is happening here is a bit different. Like, of course, the same concepts apply. Like, we're going to catch the error, and if it's not nil, in this case, we're going to completely shut down the application. But let me explain what I mean by that. So listen and serve, like I told you before, is what's allowing us to create a long-lived application. Like the application is going to run continuously. So in the case of listen and serve, nothing should actually ever be returned. It should always just run continuously. So if anything is ever returned from listen and serve, it means that there was some issue. That's why here we're using log.fatal, because log.fatal will completely exit the application. So in the example before, we were just printing out the error, right? We weren't like completely shutting down the application when we received the error. But in this case, an error is actually fatal to the application. Like if listen and serve isn't working, our application isn't working. So we need to just completely close the application. So the way listen and serve works is it won't return anything. It'll just keep running. And if something happens, then it returns the error. So in our case, if something happens, we'll catch that error and shut down the application and print the error to the screen basically. But in our code, we should never actually reach this line. The application should just be running here and we should never actually reach this line unless something bad happens. And let me show you what I mean. So if we do go run main.go, you see that the application is just running continuously. Like you see nothing's being printed, but our terminal prompt is never coming up again because the application is just running right now. So the program's just running, right? So in order for us to stop this program right now, we'd have to press Control C. And as you can see, now we can input commands into our terminal. So when we actually run the server code, the server is just supposed to run continuously. It's not supposed to stop. It's supposed to keep running. And actually, let's change the name actually. We can change the name of this file so it makes more sense. Let's change this from main.go. Let's hit refactor, rename, and let's rename it to server.go and then hit refactor. So now our file is called server.go because that's actually what it is. This is the server code. Like when this code is deployed to some production server, it'll run on the server. So we do go run server.go on the server. And then now our server code is running. Like it's a long-lived application. It just continues to run. And it's just while it's running, it can listen to requests from the front end. It can listen to and receive the requests and handle the requests. So right now, as this server is running, the code is on this line of code here. It's just running listen and serve. It's just running it continuously. Now, if there's an error, then an error will be returned from this and the server will stop running. So let's try and see what that looks like. So we'll press Control C here to stop the server again. And let's move this out of the way. So let's see what happens if we put some invalid address here. So let's just change this to invalid. And then let's go back to our terminal and try to run the server now. And let's enlarge this here. So now, as you can see, we ran the server and it tried to listen on the address we provided, but the address we provided was just a string that says invalid. There's no port, so the port is missing in the address. So in that case, the error got returned and it got put into this variable. And then we checked to see if the error is nil. The error wasn't nil, so we logged the error. And this is the error that got logged. So we can actually comment this out and we can just do format.print line, something bad happened. And then let's try and run this again. And now you can see it prints something bad happened because when the error wasn't nil, we just logged our own message. But before we were logging the error that was actually returned. But you'll also notice that we didn't use log.fatal, we just used print line, but the application still ended. But that's because if this function returns an error, then it's not going to run continuous anymore. Like if it's returning an error, it means it stopped. So then we arrived at this line and we printed it, and then this block of code was finished, and then the function is finished. But yeah, that's how the error handling is working with this listen and serve with this long-lived application. And that's how error handling in Go works in general. So I hope that makes sense to you because we'll be continuing to use this error handling throughout the rest of this tutorial. So anyways, we can go ahead and start testing out our endpoint now. Actually, wait, there's one more thing that I wanted to go over. So it's quite simple actually. So this handle create payment intent function. So if you remember, when I first introduced functions to you, I explained how the definition of the function is this here. Like this is where we're creating the function, right? And then I explained that to actually call or invoke the function, you have to use the parentheses, right? And in this case, we need to pass in parameters or arguments here. So we're getting an error under the parentheses. But the point is, invoking or calling the function, you need to use the parentheses, right? But you might notice here, we're not using any parentheses. We're just passing the function. And this is because we're not calling the function here. Like we're not invoking the function here. We're just passing it to this handle func function. And this handle func function is going to call the function for us. And actually, to explain what I mean by that, I have to actually show you. So let's go ahead and create two functions here. So we're going to do function 1, and function 1 is going to take in function 2 as an argument. So we're going to create a parameter called function 2, which is going to be a function that takes in no arguments. So it's just going to be a function that takes in no parameters. And when function 1 receives function 2, it's going to invoke function 2. So we're going to actually use the parentheses here because function 1 is actually going to call this function 2. And then we'll create function 2. And just keep in mind that this function 2 doesn't actually need to be called function 2. Like function 2 is the name that we're calling it within function 1, but we can pass any function that fulfills this type, a function with no parameters, into function 1, and it'll be called function 2 within this function. So actually, to show that, let me just name this something other than function 2. So we'll do func, another function, and it takes no parameters. And what this function does is it prints another function was called. So now, inside of here, once again, let's comment this out. We're going to call function 1. So we're going to call function 1, but function 1 expects us to pass in another function. So we have to pass in the other function that we created, which is called another function. So we'll pass that in, another function. But as you can see, when we're passing it in, we're not invoking it. Like that's going to cause an error. We're not invoking it because we're not the ones who are going to call it. It's going to get called inside of function 1. So we're just going to pass in the function. So we're invoking function 1, and we need to pass in another function as an argument. So we're going to invoke function 1. And as you can see, function 1's definition is here. And what it's going to do is it's going to actually invoke function 2. And function 2, we're passing in another function as function 2 here. So then this is going to get invoked, which means this is going to get printed to the screen. So if we go to the terminal here and let's clear and do go run server.go. And as you can see, another func was called because in Go, you're able to pass actual functions as arguments to other functions. And in programming, this is called a language that supports first class functions. So the fact that we're able to pass functions as arguments to other functions means that the Go programming language supports first class functions. But the reason I explain that is because I want you to understand what's actually happening here. We're passing in this function here, right? But we're not invoking it. But this handle function that we're passing this function to, it's going to invoke this function for us only if it receives a request to this endpoint. So that's exactly what's happening with this handle function. So that should be clear to you at this point. So let's go ahead and delete that. And now finally, we can get into testing out the actual sending of requests to our server. So remember, whenever this handle create payment intent is invoked, we're just going to print endpoint called. And this will only be invoked if our server receives a request to this create payment intent. Then this gets invoked. So handle func is basically mapping this endpoint to the calling of this function. And when we do listen and serve, the HTTP package internally, it knows which endpoints we're listening on because we define them here. So we're defining this endpoint here with this functionality. And internally, this HTTP listen and serve, it knows about this line of code that we have here where we're assigning this endpoint to this function. So when we call our endpoint from our front end, or in our case from Postman, because we're going to use Postman to emulate the front end, we're not going to call it from the actual front end. The Postman is essentially like, instead of sending the request from the front end, we're just going to send it from Postman. And it's easier to test that way. But later on, we'll also test it with the actual front end. So you'll be able to see it done both ways. But for now, we're going to test it with Postman. So we're going to run our server and we're going to send a request from Postman to this endpoint. And what's expected to happen is this function should be called, which prints out endpoint called. And remember, the address that's being listened on is our local host, which I explained to you. And actually, you can also use 127.0.0.1. That's also the same as localhost, as I explained to you before. So if we did this, go run server.go, you see we get no error. It's running on localhost, which is this IP address, which is your internal IP address. It's actually called the loopback address. But like, if you want to dig deeper into that, then you can go ahead. But for the purposes of this video, the explanation I gave you before of what the localhost IP address is, that's good enough. So let's stick with calling it localhost though, just because it's easier. So this is our address that we're listening on, and this is the port that we're listening on. So on Postman, we should be able to send the request to this address, this port, this endpoint. So let's try that. But first, we have to run the server. So let's clear and do go run server.go. And our server's running. Actually, to make it easier to see that our server's running, let's Control-C on that. And right before we call listen and serve, let's just log.print line, and we'll just print out listening on localhost port 4242. So whenever we run the server, right before it starts listening, it's going to print that it's listening. So we can actually see that the server is running. So we'll clear this and do go run server.go. And now you see it gives the date and the time. That's because this log package's print line prints the date and the time. And then it says our message, listening on localhost 4242. And actually, to make it look more like it's listening, we can put ... here. So now we have listening on localhost 4242. So now we should be able to go to Postman and actually send a request to this address at this endpoint. And then in the terminal here, it should print endpoint called. So let's try that. So let's go and open Postman. And we'll just do localhost 4242/create payment intent. And let's try and send this. Now down here, you see that it says that the response that we got was 200 okay. And 200 just means okay, essentially. It's the standard response for a successful HTTP request. So 200 is the standard response when the request was successful. So if we go back into GoLand, we should see that endpoint was called. Now, what do you think is going to happen if we try to call an endpoint that doesn't exist on our server? Right now, we only have create payment intent, right? So what if we call some other endpoint that we don't have? So maybe let's try and call the health endpoint that we never made, and then we hit send. You can see now the response is 404 not found. Now 404, the requested resource could not be found. That's because we don't have the endpoint or the interface for the health endpoint on our server code. So the response is that resource isn't found. That endpoint is not found. But we can go ahead and add it here. So let's go ahead and add another handle func, and we'll call this one health, and we'll name the function handle health. And now we need to create the function handle health. So we can just copy this function and we'll change the name to handle health, and we'll change this to okay. And then we'll need to restart our server. So we'll do go run server.go, and then let's go ahead and try and send a request to that endpoint again. And now you can see we get 200 status okay. So if we go back here, you can see okay gets printed to the screen. But that actually doesn't tell the sender of the request anything, because we're printing this to the server's terminal. Like the sender, the person sending the request to our server, doesn't get this message. But just like it's possible for the sender to send us a request, it's possible for the server to send the sender a response. So now that's what we need to go over. We need to go over how to send a response back to the person sending the request. So let's go ahead and Control-C and stop our server, and let's write some code in our health endpoint to send a response to the front end or the person calling our server, letting them know that our server is running and up. Now, in order to explain how we can send a response to whoever's sending the request to our server, I need to introduce another concept to you. So we're going to come back to this handle health function, and for now, let's just comment everything out in main. So I need to introduce the concept of storing a list of values in memory. So far we've learned about storing single values in memory as variables. So for example, maybe we have var name string equals James. So that's how we store a single string value, a single name. But what if we want to store multiple names in the same variable? So instead of just having name, what if we wanted to have a variable names, plural? Well, in that case, we need to use what is called a slice. And in Go, a slice is a list of items, essentially. essentially. And to declare a slice, we would use these two brackets here. So we first put the two brackets, and then right after those brackets, we put the type of item we want to store in the slice. So for example, if we want to store multiple names, string names, then we put these two brackets, slice of string essentially. And what that looks like is we'll set it equal to, and essentially what we're trying to create is something that looks like this. So just a list of names enclosed in these brackets, right? But you notice we have an error here. And that's because the syntax in Go for actually creating a structure like this is actually a bit confusing, to be honest. So let me show you how to actually create a list that looks like this in Go. So we're trying to create names, right? And it's a slice or a list of string values as the names. So in Go, we have to actually put the type like so. And then here we have to put these curly brackets. And now, as you can see, we no longer get an error here. So we're essentially creating a list of names, and the names that are included in the list are these names. So if we were to print names, and we can just delete this single name and open our terminal and do go run server.go, you'd see that it prints out this list of names, James, Bill, and Jack. And these lists are actually 0 indexed. So what I mean by that is each one of these names can be accessed using an index. And an index is just the count from 0 to the last name. So this list here, or this slice, has 3 names in it, right? So the length of this slice is 3. There's 3 names in the slice, but the index starts from 0. So actually, Jack here isn't the 3rd index, it's the 2nd, because it would be 0, 1, 2. So if we want to access Jack, we can print names 2, the index 2. And then we go to terminal, go run server.go. And as you can see, now it prints the single name Jack. So that means that if we want to get just the individual name, the first name in the list, it would have to be 0 because there's 0 index. Remember, 0, 1, 2. It's not 1, 2, 3. It's 0, 1, 2. And this applies to any programming language. The lists are 0 indexed. So if we want to print the name James, we have to print name at index 0. And as you can see here, we just use these brackets to access a specific index of names. So we'll do go run server.go. And you can see now it prints James. And as you can probably guess, Bill, the index would be 1. So if we want to print Bill, we would change this index here to 1. So that is called a slice in Go, which is just a list of values. Now, this slice in particular contains strings, right? But what if we wanted to contain something else? So we can change the type to, for example, int. And of course, we have to change this to int. But now you see we're getting errors here because these aren't ints. We can't store strings inside of a slice of int. So we need to change all of these to ints. So we can do 1, 2, 3. And actually, to make it less confusing, let's just do 50, 60, and 70. And if we print names 0, it's going to print 50. So as you can see, it prints 50. So it's the same concept. It's just we're changing the type. So in Go, you have to be specific. Like you have to say what type for everything that you declare. So that means that Go is a type-safe language. But there are other programming languages out there that are dynamically typed, where you don't have to specify the types of variables. But in my opinion, that's just a recipe for disaster. So it's good to have the strictness of the type safety, in my opinion. So anyways, that is a slice in Go, and we're going to need to make use of that when we're actually responding to whoever sends the request to our server. So let me show you what I mean. So let's go ahead and delete this, and let's remove the comments from our main code, and let's go back down here to our handle health function. So here's where we actually realize what this response writer and request is. So remember, the functions that we pass to handle func, they need to take in as parameters the response writer and the request types, which are provided by the HTTP package. And the reason they need to do that is because these types are the types that we need to use to both respond to the requester and read the request from the requester. For example, when we're responding to whoever sends the request to our server, we're going to use this response writer, which we have as W here. So W just stands for writer. It's just a short way to do it. Like you could, if you wanted to, just put writer here instead of W, and here you could put request. And maybe let's just do that to be more verbose so you can kind of understand what we're using these variables for, or what we're using these parameters for. So we're not going to print OK anymore. So when the requester sends a request to the health endpoint, we want to send them a response that essentially tells them that the server is up and running. And the response is going to be a slice of bytes. Now, it's going to look super confusing right now when I write this out, but don't worry, I'm going to explain it. So just bear with me. So first, we're going to create a variable, and we're going to call it response. And the type of this variable is going to be a slice of byte. And we have an error here because I forgot to write var. So remember, you have to have var when you're actually assigning values to these variables. Actually, there's another way to do it where you don't need to use var, which I'll show you in a second. But first, let me just show you this. So we're going to create a slice, the same as the one I just showed you, but the type of the values inside of the slice are going to be byte. Now, byte, I haven't introduced this type to you yet. So I'm introducing it now, essentially. I'm going to tell you what it is now. But first, let's finish writing this out. So we're going to create a variable called response, and it's going to be a slice of byte. And we're going to set it equal to slice byte parentheses server is up and running. Now, let me explain this part. So this syntax here, where we're using parentheses here after the type, this is the syntax for converting one type into another type. Now, let me show you what I mean by that. If we have var some number type int, and we set it equal to 22, and then we do string parentheses, and then put some number in there, and we set this to var number as string equals. Here, we're converting some number, which is an integer, into a string. So if we were to print number as string, it would look like this. It'd be a string version of this integer, because since we're using the type plus the parentheses after, and we're putting the number in there, we're converting this number, which is an integer, into a string here. And that's the same thing we're doing here. We're converting this string that says server is up and running into a slice of bytes. Now, what a byte is, I have to explain what a byte is. So actually, let me cut this from here, and let me put this in main, and once again, comment out our main code for now, because it's important that you understand this. And then let's just do, let's assign this string here to a variable to make it clear that it's a string. So we'll do var response string equals server is up and running. And then we'll change what gets passed into here to response string. So now we're creating the response string variable here, which is this string, and then we're putting it in here, which is going to convert it to a slice of byte. And then let's format print line response, and let's open our terminal and go run server.go. Now, as you see here, it's printing out this list of numbers, right? And this might be quite confusing to you, but let me explain to you what this is. So each of these numbers is a byte, because remember, this is a slice of byte, and a byte is just a UTF-8 encoding. Now, that's going to sound confusing right now, but I'm just going to show you. Let me just show you what that is. So we can go to Google, and we can type in UTF-8 chart. And then we can go here and select this UTF-8 code page, and we can go down here and we'll see this chart here, right? And we can go back to our editor and we can see this byte here is number 83, right? So keep 83 in mind. Now in this chart, we can search for the number 83. So here, 83. So the decimal value, 83, is equivalent to all of these different values, right? So in hex, 83 is equivalent to this. In UTF-8 hex, 83 is equivalent to 53. And the character that it's equivalent to is a capital S. So the Latin capital letter S. Now, it's the 83 is equivalent to the Latin capital letter S. And if we go here and we see the string here, the first letter of the string is the capital letter S. So that means that each one of these characters is a byte, and that's including the space here. So if we count it, so 1, 2, 3, 4, 5, 6, 7. So the seventh byte in here, 1, 2, 3, 4, 5, 6, 7, 32 should map to a space. So we go back to Chrome and we go for 32. So 32 here, the decimal value 32, you can see here, it's space. It's a character space. So that's all a byte is. A byte is just what it maps to, the decimal value of the character. So what we're doing here is we're converting this string into a slice of bytes. So it's taking every character in this string and putting it into this list of bytes as its byte value. So if you literally went through each one of these letters and the spaces included and even punctuation included, every character in the string, if you went through every one and translated it using that chart, this is the list you would get. And that's what we're doing. We're converting the string into a slice of these bytes here. And that's because when we send the response over the wire, this is how we have to send it. And when the requester receives the response, they're going to be able to, on their end, translate this stuff back to something that's human readable. But you don't need to know the details about that. You just need to know that when we send the response in Go, we need to send it as a slice of bytes. So I hope that makes sense. So now you should know what we're doing here. We're converting the string that we want the receiver to read into a slice of byte. And I just explained what bytes are. So now we can move this stuff back to where we got it from, our handle health function. And don't forget to remove the comments from your main code. So now we have the response that we want to send to the person sending the request to our server to check the health. So we want to send them the server is up and running. So now to send the response to them, all we have to do is take our writer, which is this variable here that HTTP package provides for us. We take the writer and we do the function write. And if we hover over this function, you see that write takes a slice of byte and it returns an integer and an error. Now, we don't need to worry about this integer return value, but we do need to check the error because remember I told you in Go, we're responsible for handling errors on our own. So if an error gets returned, we do need to handle it. So since this write function takes a slice of byte, we can just pass in this response that we just created up here because it's a slice of byte. But we need to handle the error and ignore this integer. So to ignore the integer. So in Go, okay, so here's a new concept. So in Go, you can receive multiple different values in a response from a function. So like, for example, if we created a function here called returns multiple, here, we could return multiple things. We could return a string, an int, an error. So in this case, we want this function will return 3 things, right? 3 values. So return, string, and int. And let's not do error because I don't feel like importing the error package. Let's just do bool and a bool. So this function is returning 3 separate values, right? So that means that when we store the response from this function in a variable, we have to store 3 different values. So if we go here and we try to do it with just one value, so let's do var something string equals returns multiple. Now you see, if we do this, we get an error. It says assignment count mismatch. We only have one variable that we're assigning a value to, but it expects 3. Because you can see here, func returns multiple, returns string, int, bool. But we're only catching a string. So here, we need to catch 3 values. But to catch these 3 values in a clean way, I need to teach you a new way of actually assigning values to variables. So to catch all 3 of these, we can do this. Now, you'll notice some new syntax here. So usually we have to use var and then the type with the name of the variable, right? And usually we just use this regular equal sign to assign the value to the variable, right? But here we're using this weird colon equal sign, right? Well, this colon equal sign is like a shortcut. Like Go can actually infer the type based on the function. Like the function tells Go that a string, int, and bool is returned. So Go can just infer from that these 3 variables should be int, string, and bool. And the same if we were to create a string. We can create this is a string, and we can do the colon equals, and we can put string here, and Go knows this is a string, so it can infer that this is a string. So this is actually, okay, we can do this way. So this is like the shortcut to this long way that we've been doing it. But the reason I've been doing it the long way is because I wanted you to learn about the variable keyword and assigning specific values with specific types. But from here on out, we're going to start to use this shorter syntax like this shortcut here with a colon equal signs and have Go just infer the type of the variable. So these are perfectly valid lines of code. The only reason they're red here is because we're not using the variables. So Go wants you to use a variable if you assign a value to a variable. So if we did format.println, this is a string, it's no longer red. And the same thing would happen if we printed these. But yeah, this is the easy way to actually assign a value to a variable without needing to write var and then the type and all that. So we can remove that. And here we can actually just do colon here. And you can see there's an error because we need to delete this and delete this. But now you can see Go just infers that this is a slice of byte. So the colon is very useful. You can just use this instead of needing to write out the long stuff that I taught you in the beginning. And we're doing the same here. So we're receiving 3 values from this function and we're using this colon so Go can just infer the types and from left to right, like the same order that the values are returned. So the same order here. So the string is the leftmost value, the int is the middle value, and the bool is the rightmost value. So when we return it, we do the string as the leftmost value, the int as the middle one, and the bool as the rightmost value. So we're returning 3 values, and we could do like format.println, and we can do it for each value. And I keep accidentally forgetting the T. And in this case, some string would get printed first, then the int would get printed, and then the bool true would get printed. Now, I explained all of that, the part about returning multiple values from a function, because this writer.write function, it returns 2 values, but one of the values we want to ignore. So what we can do is, to ignore a value, we can just put an underscore, and then we don't want to ignore the error, of course. So we can do it like this. So this write function returns an integer and an error. We want to ignore the integer. So for the first variable, we just put an underscore. We just ignore it. And then the second one, we use the conventional name ERR for error. And remember, we need to check and see if the error is nil. That's how we handle errors in Go. So just get in the habit of doing this. So if error not equals nil, then we have to do something. And in our case, we're just going to print the error. We're not going to do anything crazy. We'll just print the error. But yeah, you're going to see this if error not equals nil all over Go code. And you're going to need to write it all over Go code as well. So just get used to this pattern here. So we catch the error, potentially catch the error. So if the error is not equal nil, we'll do this code here. But if the error is equal nil, then we skip this part and we'll go down here, right? But the function doesn't have anything after this, so the function will just end. So now, when we send a request to this handle health via Postman, we're just going to send the response, server is up and running, and then that's it. The function's going to end. If there's an error sending the response, the error will get printed, and then the function's going to end. So let's go ahead and run the server and try this out. So we'll go to the terminal, let's clear, go run server.go. So now our server's running. So now let's go back to Postman. And it's going to just keep asking me to update. Anyway, so we have our localhost 4242/health. We'll send the request. Now, as you can see here, we get a 200 response, which means it's a successful request, and we received the message. Server is up and running because we returned that in the response. We wrote that to the response. That's what the response writer is. It writes to the response that gets sent back to the caller, which is right now it's us sending the request from Postman. So if we go back in here and we stop running the server, this is the point of the health check endpoint. We want to check the health of the server. So if we go back to Postman, so remember we're an entity that's not part of the server. So like we don't know if the server is running or not. So we would want to, what if we wanted to check and see if the server is running? We'd send this request to the health endpoint, and you see we get could not send request because the server's not running. So we'd know then like, oh, the server's not running. We can't access the health endpoint. Like we check the health, server's not running. So if we go run server.go, send the request again, now we know the server's running. So that's the response writer. That's the writer. That's where we're writing to the response that gets sent back to the caller. But the request is the request that we receive from the caller. So we're going to leave this health check code here because we want to have the functionality for the caller of our server to be able to check the health. But let's also see what this request does. And we'll just test that out in our actual handle create payment intent endpoint. So we don't need to print that anymore. So here, let's also change the variable name of the parameter to request and writer just to be more verbose. And I don't know, it's a bit long, so it's kind of hard to see. But yeah, the end of this function, you basically know what it is. It's the request and the writer. Those are the parameters. So if the person sending the request actually sends us some type of message in the request, we could actually read it inside of this function. And coincidentally, in our handle create payment intent code, that's actually something that we're going to have to do. And we're also going to have to make sure that the person calling this endpoint is using the proper request method. So when sending HTTP requests, there are different request methods that you can use. So if we go to Postman here, this here is the request method. So if you hit this drop down, you can see all of the methods available to us. Now, in this tutorial, we're only going to be working with the post method, but if you want to dive deeper into the rest of the methods, feel free to do that as well. But we're not going to go too deep into all of the methods in this tutorial. But the names of the methods kind of give you a general idea of what each one does. So maybe there's an endpoint to delete some resource on some server. You would use delete. Or maybe you want to patch some resource or copy some resource. But the most common ones you're going to see are get and post. So those are the ones that we'll focus on. So get is the one that you use to retrieve data from a server. And post, we're generally going to be trying to provide data to the server. So for example, our health check endpoint, we could just use the get method because we just want to get some information. So what gets returned from the server, the information, the server's up and running, that's the information that we want to get. But in the case of creating customer payment intent, we want to post some data, which is basically information about what the customer wants to buy from that product store page. We want to post that data to the server. We want to send that data to the server. And with that information, the server is going to be able to do something to create the actual customer intent, which I haven't explained exactly what that part of the flow is yet, but I'll get to it. But first, I want to go over the fundamentals that you need to know to actually do this. So we need to make sure the request method is a post method on our server. And that's for when they call the create payment intent. Create payment intent. When they call this endpoint, we're going to require it to be a post method endpoint. And we can see what the request method is by using this request variable or parameter, which is the type request from the HTTP package. So let's see what I mean by that. So we're going to say if request.method. So as you can see, this request parameter, the HTTP package provides the functionality to check the method of the request in its own type that it gives us, that HTTP request type, which is here. So we can check the request method. So we say if request method is not equal to post, then we can do something. Now let me take a step back here. You probably have never seen this before. So this just means not equal. Remember equal, when we check if something is equal to, we do two equal signs. But to check if something's not equal to, we'll do exclamation and then equal, not equal. So if request method is not equal, and I said you never saw that before, but actually we've been using that for this if error is not equal null. So I should have explained that earlier, but I hope you understood when I was saying if error not equal null. But yeah, this means not equals. So if request method is not equal to post, we want to return an error. And actually the HTTP package provides a function for us to return the error or to return specific types of errors to the caller without actually needing to write to the response writer manually like we've been doing with the health endpoint. So with this endpoint, we wrote to the response writer this message. We did it manually, right? We used the writer's write method here. But here, we're just going to use the HTTP package.error, and this function takes in the response writer and the string that we want to return as an error and the error code that we want to send them. Now the code is the part that I've been showing you. So the code is this part here. So if we go back to Postman, this is the code. So if the response is successful, the code is 200, right? Well, there's multiple different codes for different types of response in the networking and programming world. So the HTTP package actually provides all of these for us. So let me just show you what I mean. So we can pass in our writer, right? Which this error, we're passing in this response writer, and this error function is going to use this write function for us. We're not gonna have to do this. It's gonna do it for us under the hood. So we're gonna pass in the writer, and we also have to pass in the error string and the code, right? We don't even have to write out the error string ourselves. We can just use http.statusText, which is another function from the HTTP package. So status text, and you can see here status text returns a text for the HTTP status code. So here we just put in the code. So HTTP dot, and the code that we want to use is the status method not allowed code. Now you can see here all of these codes that the HTTP package provides for us. So we can just type status method not allowed. Now this is provided for us by the HTTP package. As you can see, status method not allowed is going to be translated to the code 405. So this is the code that we send, the HTTP response code that we send when somebody tries to send a request using a method that we don't support for that particular endpoint. So this endpoint, we're creating it so that it only supports post. So if it's any other method, we're going to say that we don't support that method by sending the code 405. And these codes are convention. Like these codes are used throughout the networking and programming world. Like, so a 405 is a universal thing. So You don't want to just be making up your own status codes or whatever. You need to look up the proper status codes for the proper types, for the types of response that you want to send. And this HTTP package makes it easy for us because it provides basically the code given the name of the error that we want to return. So status method not allowed. Like we don't want to allow anything other than post. So this error HTTP error function takes the writer, then it takes the status text. The status text is created by passing in the code to the status text function. Then the status text function, it knows what text to send back as the error because it knows the code. It knows what the code means basically. It knows the code 405 means that the method's not allowed. So the text that it's going to send back is going to basically say something like the method's not allowed. And you'll see what I mean by that soon. And then for the code, we put the same thing, http.status method not allowed. And this is just going to be the code, not the text, just the actual number, because we're not passing it to the status text function like here. And then after that, we're just going to return. And return in this case just means like return out of the function. Like the function's finished. We want to finish the function here. If they send a request that's an invalid method, we want to send that response and just finish the function. We don't want to continue with the function. But if they do send the right method, then this will get skipped over. So we wouldn't return out of the function, and we continue down here with the rest of the code. And you'll see what I mean soon. But first, let's just test this part here where we're sending this HTTP response, basically saying that the method's wrong. So let's open our terminal and restart our server. Go run server.go, and let's open up Postman. And let's do a GET request to this endpoint. Now remember, we only accept post requests to this endpoint, and let's send it. Now as you can see here, we get 405 method not allowed, and you can see the text method not allowed, the text that got sent back, that got written to the response based on just passing this 405 into that text function. So let me show you. So remember, this is taking the writer and then the error as a string. So this method, which is just a number, 405, is getting mapped to a text. And maybe I can just show you what I mean by that by printing. So if we do format, print line, http.status method not allowed, and let's just take this and put it into our main function. And let's comment out our main code. And let's just run this and see what gets printed. And actually, I need to put a T here. Now let's stop running the server and do go run server.go again. And you can see it just prints the number 405 because this is just a variable name for the number 405 that the HTTP package provides. Now, that means that we could even just change this to 405, but that's not a good way to do it because it's possible for us to put the wrong number in here or something, or maybe we don't know the exact code that it's supposed to be. And it also makes the code harder to read. So yeah, but when you pass 405 into status text, it's going to print out the text version of the code. So for example, if we just copy this and we paste it and we do format.println. So now we're going to print the result of this function. We're going to print what's returned from this function. So we could go run server.go. Now you can see what gets printed is method not allowed because we're passing in the code to the function and the function returns the string. It returns the string value of the code. Hope that makes sense. So we can delete that and let's uncomment our main code again. And now let's go here and do print line and we'll do request method was correct. So when we run the server now, if a request gets into this endpoint with a method that's not post, it's going to return the error, right? And actually, let's change this back to the actual one that's provided. Anyways, if a request gets into this endpoint and it's a method other than post, then of course we're going to return this error, the status 405 error, right? Method not allowed. But if they do send a post method, this gets skipped and then we go down to this line of code. And then after this gets printed, the function finishes. So if the method's post, then we should see request method was correct. So let's run the server, open Postman, and let's send it again with the wrong method. You see 405 method not allowed. But now let's send with post. So you see 200, which is an OK. And then we go back to Goland and you see request method was correct. So what we're doing here is in this block of code, we're validating that they're giving us the right request method. If they're not, we're going to return an error. If they do give us the right request method, we'll continue with the function. And from there, we'll continue with the functionality of handle create payment intent. But before we write out the rest of the functionality for this function, I need to actually explain to you the flow of what's going to actually happen when a user wants to purchase a product on that front-end webpage and the front-end sends the request to create the user's payment intent to our backend server, because I haven't explained that yet. And you need to understand that to understand what's actually being built here. So let's get into that explanation. So the Stripe payment flow is going to involve 3 entities. And those entities are the front end, the Stripe server, and our server where we're writing the API in Go. So Stripe has its own servers and its own APIs, and both our server and the front end are actually going to be communicating with this Stripe server. So what's going to happen is if the customer wants to buy a product, they will select the product they want to buy and go to the checkout page. When the customer hits that checkout page on the front end, a request is going to get sent to our server, and that request is going to be the create payment intent request. Now, when our server receives this request to create payment intent from the customer, our server is going to send a request to Stripe's API to create that payment intent. So the actual payment intent gets created on the Stripe server. So let's just say this purple ball is the payment intent. So when we send the request to Stripe to create the payment intent, it's going to spit out this purple ball and send it back to us. And this payment intent actually has like a secret key associated with the customer that the front end sent the original payment intent for. So our server is going to return that secret key to the front end. So we'll say customer key. So this customer key essentially maps this payment intent to this customer. Now, something important to note here is Stripe has access to this same payment intent. So essentially Stripe just sent us a copy of this payment intent. So Stripe has this same payment intent and ours is essentially just a copy of that one. So just to recap, step 1, the front end sends the payment intent to our server. Step 2, we send create payment intent to the Stripe server. Step 3, the Stripe server creates this payment intent object and gives us a copy of it, and that object has an associated key with it. Then step 4, our server sends that key back to the front end. So now the front end has the key for the payment intent that we requested to be created by the Stripe server on our server. So now when the customer actually confirms their payment, the front end has a Stripe library or like a Stripe backend built into it. Like, so the front end that I pre-built for you, it has the functionality built into it so it can contact the Stripe server. So when we return this customer key to the front end, when the customer confirms their payment on the front end will send a request to the Stripe server to confirm payment. And how does the Stripe server know whose payment we're trying to confirm? Well, when they send the confirm payment request to the front end, they provide the customer key in the request. The Stripe server can then associate this customer key with this customer's payment intent, because remember, the payment intent object is still on the Stripe server as well. So once the payment is confirmed on the Stripe end, Stripe will send a response back to the front end, telling the front end the payment was successful. And then from there, the front end can redirect the customer to a payment successful page. Now, there are some advanced things that would need to be added to our server code and to this overall payment flow if we were to actually deploy this to a production server. For example, since the front end confirms the payment with Stripe directly using the customer key, our server doesn't at the moment have any way of knowing if the payment was successful. So additional functionality that we might want to add to our server later on down the line is we would want to create what's called a webhook, which is basically an API endpoint that we provide to the Stripe server. So the Stripe server can send us a request telling us that the customer successfully completed their payment. But we're actually not going to do that in this video. Maybe I'll create a second video down the line where we add that functionality, but we're not going to add that to this server for this video. So this is the payment flow. So remember, the front end sends the create payment intent request to our server. Then we send a request to Stripe telling them to create this payment intent object. Stripe creates the object and gives us a copy of it. That object contains the customer key associated with this payment intent. We send that customer key back to the front end. Then whenever the customer confirms their payment on the front end sends a confirmed payment request to the Stripe API or Stripe server with that customer key. Stripe then associates that key with the payment intent object that it has on its server and will confirm the payment and send a response back to the front end saying the payment was successful. And we can access the funds for the payments that we receive by logging into our Stripe account that we logged into earlier, the one where we had the Stripe dashboard and we had to copy our keys. So that's how the payment flow is working with Stripe and our backend API. So I just realized that I've been showing you guys all of these tools provided by the HTTP package, such as the status text function and like the status methods that the HTTP package provides. And you're probably wondering, like, how do I know about all these tools provided by this package? For example, this HTTP package is one of Go's packages in its standard library, right? But like, how do I just know that we can whip out these tools? Like, how do I know about these things that we're using? And essentially, before ever working with this package, I didn't know about these tools. So how do I know about them now, I guess, is what I'm saying. So this is a very important part of programming. So I should have mentioned this sooner, but actually this is probably one of the main things you'll do as a programmer. And that is reading documentation. So basically, if we go to the top of the file here, the package that we're using all these tools from is this net HTTP package, right? And this is a package in Go's standard library. So the reason I know to use all these different tools provided by this package is because I read through their documentation, or rather I started reading through their documentation when I first started making APIs in the Go programming language. So their documentation is quite extensive. So of course I didn't read all of the documentation, but I've read a lot of the documentation for the things that I use, the tools that I use provided by this package. And I just want you guys to get in the habit of doing that because that's basically how you're going to build things on your own when you're not following tutorials. You're going to have to look into different packages provided by the language. And there are external packages as well that aren't provided by Go, like that aren't part of Go standard library, but are still very useful packages that the community uses. So for example, we can just search for this net HTTP Golang and it'll take us to the Go programming languages like package page, and all of the packages in Go standard library, the documentation for all of them can be found on this site here. And this site provides information about like getting started with the package, the things of the package, the type of things you can do with the package, additional information. There's a whole index here that tells you about every aspect of the package. So essentially when I'm building something in Go, for the packages that I'm using, I'll go online and I'll read through their documentation to see what tools are available to me. And I'll just make use of those tools as I see fit. Like if I see something that's useful to what I'm building, I'll just make use of it. And then from doing that, you start to familiarize yourself with certain tools. Like this HTTP package is a very common tool in Go. So like you'll find yourself using it very often as a backend engineer. So eventually you start to become familiar with the different tools that it provides, and you start to kind of get like a routine going when you build an API. Maybe you have like a skeleton that you always use to create your APIs or something like that. And that's basically how I know about all of these tools that I'm using and showing to you provided by this package in particular, and any other package that I use. I know about the tools because I've read through the documentation for them online. So like you can do the same thing with this Go's log package. Like there's a lot of tools available to us in this log package as well. So we can just go back to Go here and then docs and then hit standard library. And we can just look through here and look for the log package. So you see the log package here, and you also see the format package, which we've been using a lot as well. But yeah, you can see the log package here, and you can click the log package and get more information about that one. And this is how I'm getting information about all these packages as I'm building things. So you're going to need to get in the habit of doing this as well as a programmer. You're going to have to get in the habit of reading documentation and understanding how certain tools can help you to build things. And when you become more advanced, you're going to need to start learning how to reverse engineer code and understand how code is working, because sometimes people write code and there's no real documentation to tell you how the code works or how you can use certain tools provided by the code. So you have to learn how to reverse engineer code as well. But that's a more advanced technique. For now, I just want you to know how I'm actually coming up with these things like this status method not allowed here. Like, how did I know that this even existed? It's because of the documentation. And also, you can actually go to where this exists in the HTTP package's code by pressing Control or Command and then click. And if you hit Command click, it'll take you to the actual code where this is written. Like this is the code where it's saying that this value is equal to 405. And these are all constants. Like they're variables, but they're variables that don't change. Like this variable would always be 300. The value would always be 300 for this variable because it's a constant. And you can see here, we use the keyword const to make these constant variables. So if we go back to our code here, if we type in const does not change, and we set it equal to does not change. If we go into main and we try to assign does not change a different value, so does not change equals another value. If you hover over this, you see that we cannot assign to does not change, because once we set a value for a constant, it can't be changed. We can't assign a different value to it. But if we create a regular variable, so does change, and we'll use that new syntax I taught you, can be changed, and then we change does change to it was changed, you can see if we do print line does change the first time and then the second time, it's going to print a different value the first and the second time we print it. Oh, and that's another thing I forgot. So this colon here, it can only be used the first time you assign a value to a variable. The second time you don't need to use it. So if we hover over this here, it says no new variables on the left side of the colon equals, because this variable already exists here. We already declared the variable here. So if we're using this, it's declaring and assigning the variable, but we only need to assign a value to it, not declare it, because we already declared it here. So we can go ahead and remove that. So that's the difference between declaring and assigning a variable. So while we're at it, let me just explain that as well. So we can declare a variable without actually giving it a value. So we can do var variable name, and we can just say it's a string. And then later on, we can do variable name equals some string, and then we can print it. Now this here is declaring the variable. Like we're setting this variable up and we can assign values to this variable, but we didn't assign a value here. As you can see, we're just declaring that there's a variable named variable name that's going to be a string. And here is where we're assigning a value to the variable. Now this syntax, the semicolon and the equals, it declares and assigns the value to the variable the same way we were doing it before when we were doing var variable name string equals something. When we were doing this before, we're both declaring and assigning a value to the variable. And that's what this does. This is a shorthand syntax to do this long thing, declare and assign the value. But you can also declare a variable without assigning a value to it, and then you can assign a value to it separately. So that's the difference between declaring and assigning a value to a variable. So this does both, right? So since this does both, if we try to do it again, it's an error because it's trying to declare the variable again, because this shorthand syntax also declares the variable. For example, if we tried to do this again, it would be an error. You can see variable name redeclared in this block. And let me change the name of this so it's not so confusing. So let's just call it something. And now here you see something, the variable name something, redeclared in this block. You can't declare a variable twice, you only can do it once. Now that went a little bit off topic, but yeah, that's declaring and assigning values to variables, and that's constants as well. And going back to what I was explaining before, get comfortable with using the documentation or reading through documentation for tools that you think might be interesting to use. Like as you become more familiar with programming and you start to like it more, you're gonna actually start to get excited if you get a chance to read some documentation about a tool that's interesting to you. Like maybe some new tech will come out and then the documentation page might seem exciting for you to read because you know that you can like read through the tools available to you and think of things that you can build with it. So just get comfortable with reading the docs. That's how I'm coming up with this stuff, like this constant, using this constant here, using this function. And also another cool thing, you can actually read the code for the functions that you use from these standard library packages as well. So like, again, you can press command and click, and it'll actually take you to where the function is defined. Like this is the function definition. And the people that wrote this library for Go, like wrote this code, just like you're writing code for whatever it is that you're building. So this is the function status text, and it takes in an integer and it returns a string, as we already know. And then this is the code for it. It's really just a long switch statement. So if the code is some code, it'll return some text. It's just a super long switch statement. And a switch statement is essentially like if-else statement that we went over before. So like if code is status unauthorized, return unauthorized, etc. But you don't really need to know what a switch statement is right now, because right now we're just making use of the if-else conditional statements, and they serve the same purpose. There's some situations when you might want to use a switch instead, but we don't need to worry about that right now. So anyways, we can leave that. But yeah, that's how you like dive deeper into the code that you're using, like the libraries that you're using. Like you can check the code, you can read the documentation, try to understand things that you're using, try to dig deeper and see what's happening under the hood. Like that's how you become a better programmer, like reading other people's code, reading documentation, learning how things work, and you eventually become a better programmer when you do stuff like that. But anyways, sorry for the long rant, but yeah, so let's move on with the rest of this tutorial. So it's time for us to actually finish writing the code for this handle create payment intent function. And essentially where we left off was receiving the request from whoever's sending us the request, receiving that request and checking the method, right? We checked the method and made sure it's post for this endpoint. But remember I told you that a post method is sending some type of like payload to our endpoint to actually trigger some sort of action, and the action needs to use the payload that's provided in the request. So what I mean by that is we're going to receive from the front end a structure of data that contains the information that we need to actually create the payment intent object that I told you about. So we're going to create that object in code, and we're going to use the information provided to us in this request to create that object. So let me show you what I mean by that. And to show you what I mean by that, I need to introduce to you another type in Go, which is called a struct. So we're going to say var req for request. Since we're already using request here, we won't use that. Req struct and then brackets. Now if we hover over this, you can see that a struct is a sequence of named elements called fields, each of which has a name and a type. So this is essentially going to be the paradigm for the data that we're receiving from the person sending the request to this endpoint. And what I mean by that is we're going to define the structure of the data that gets sent to this endpoint. And whoever sends requests to this endpoint is going to be required to conform to that structure. We're creating the structure. So let me show you what I mean by that. So we're going to list the fields that we need in the data that gets sent in this request. So the first field is going to be product ID, and it's going to be a string. And when they send it to us, we're going to define the format of what this field is supposed to look like. And you'll see what I mean. It's going to look confusing right now, but I'll show you what this means soon. So we're going to put product ID here. And then the next field is going to be first name, and all these fields are going to be strings. And we're going to do last name, address, city, state, zip code, and country. And as you can see here, it's getting a little bit messy. Like the type names aren't lined up. So we can go here and right click our file and do reformat code. And as you can see, it lines things up all nice and pretty. So we can close that. So when a request is sent to this endpoint, we're going to expect the request to be this structure. So we're defining the structure here. And what we're going to do is we're going to take the request body from here, and we're just going to put it into our own request structure. And by the way, all of these have to be capitalized. So just keep that in mind. And they need to be capitalized because we need to export these values. And we need to export these values because we're going to need to pass this into another package's function. So they're going to need to be able to use or access these values. And if we do them in lowercase, they won't be exported. The same way to export a function from a package, it has to be capitalized. It's the same with this. So let's go down here. And now that we have the structure that we want the request to be in, we're going to use another package provided by Go called JSON, and then we're going to do .new decoder, and we're going to decode the request. And see this JSON here. If we go up to the top, you can see it automatically got imported, this encoding JSON. But anyways, we're going to decode this request. So here, we're going to do request dot, and what we're decoding is the body of the request. So we'll do body. Now, if we hover over body here, you see body is the request body. So remember, this request is from up here. This is the request coming from the front end. Or in the case when we test this, it's going to be coming from Postman because we're going to be sending the request. But this is that request. And the request is going to have this body attribute. Like it's going to be the body of the request. So let me show you. So if we go to Postman here, when we're sending this post request, down here, there's a tab called body. And in here, we can select raw, and we're going to provide the body, and it's going to be in the same format as that structure that we built in our code. Because if we send it in a different format, we're not going to accept it. So I'll show you what I mean by that in a second. But the request body is going to essentially look like this. It's going to have these brackets. And remember, I told you that the way that we're asking for it to be formatted in the request is like this. So in our code, we're calling it product ID with capital P and capital I, and they're like together. But in the actual request, we're going to expect it to be snake case. So this is called snake case. So we're going to expect it to be all lowercase, and each word is going to be separated by an underscore. So it's going to be product ID, first name, last name, address 1, address 2, city, state, zip, country. So here we'll do product ID, and we'll call it test product ID. So these are all going to be key value pairs. So this is the key, and then this is the value. So product ID, the product ID's value is going to be test product ID. So here we have our request body. And the way that we're writing this is actually called JSON. So instead of having it as text, we're going to change this to JSON. And when we do it that way, it'll actually give us some like syntax highlighting, and it'll tell us if we're doing something wrong in the JSON format. So JSON is just a way to format the string data. So this is what JSON looks like, essentially like key value pairs. And we're missing a comma here. So after every key value, there should be a comma, and all these keys and values should be enclosed in these brackets. So this is our request body. And in Postman, so you don't have to keep writing this stuff out. You can actually just save this. So now it's saved here. But this is the request body. So let's go back to the code. Now you see here we have our structure. We're going to receive a request body that's in JSON. So that's why we're using this JSON decoder. Like we want to decode the JSON, and then we want to put it into this Go code structure. So we're going to take the request body that's in JSON format, and we're simply going to decode it. And when we decode it, we have to decode it into a pointer to the object that we want to put it into. So this is the object that we want to put it into. This and symbol is just a pointer. But again, you don't need to understand pointers for this. So just know that we're decoding this JSON request body, and we're putting it inside of this object here, this structure here. So we're storing it in memory in this structure. So we can actually reference this structure and reference the individual fields passed in. So for example, after this line of code, we're actually going to be able to do like request.city, and that's going to give us like the value for city that was passed in from the request body. But first we need to actually check this for errors, because this returns an error. So we're gonna have to do error equals, and you guessed it, if error not equal nil, we'll log.print error. Now actually, if we get an error from this, it potentially means that the person sending the request here sent the request in the wrong structure. So actually what we're going to need to do is we're going to need to send an error response if this gives us an error. But first, I just want to show you how this code is working. So we're going to return after this. So it's going to return out of the function. We're not going to keep doing the function after that. We're going to finish the function if an error gets returned there. And let's test out what we have so far. So let's run our server, go run server.go, and let's go back to Postman. So let's go here and let's send some invalid structure. So let's just take this out for now, and we'll just send like text, this is invalid. And let's go ahead and send that. And you see that we get a 200 OK response here, but that's just the default that gets returned when we don't return a response from the function. So let me show you. If you go here, you can see that we got an error that says invalid character T looking for beginning of value. But the reason we got a successful response is because if we don't use this writer, like if we never use this writer, we get to the end of this function and we've never written any response to the writer, the default response that gets written to the writer is a success. So what we actually want to do is, if there's an error here, instead of printing the error, we want to do the same thing, HTTP error again, like we did last time. And in this case, the error can either be something internal, like some issue with the JSON decoding, or it can be an issue with the way that the request was sent to the server. And usually we want to actually validate each parameter sent to the receiver in the request, but we're not going to do all that in this tutorial. So we're just going to return an internal server error if we get an error from this decoder. So we need to pass in the writer, and for the string, we'll just pass in the error. But since the error is type error, we have to convert it to a string by doing this. So as you can see, this error function on this error, it returns a string. So this is how you return an error as a string. And then the code will be http.status internal server error. And then what we can do is we can print out all of these values so you can see them coming from the actual front end. So we can do format.println, and then remember it's in this request object here. So we'll do request.first name, last name, address 1, address 2, city, state, zip, country. And we can go into our terminal and let's restart the server. And now when we go back into Postman, we can change this back to JSON and then put in our actual JSON object, and we can send it. And as you can see, we didn't get the error returned to us, so that's good news. And as you can see here, everything got printed to the screen. First name, last name, address 1, address 2, city, state, zip code. So that's how we're receiving the request body using this request up here from the person sending the request to the server. And this is where we're defining the structure. So we're decoding that JSON object into a Go structure, and then now we have access to these values, and we can now use these values to actually finish writing the code for this endpoint. Now, this endpoint, actually the most important value that we need from the request is the one product ID. This is the one that we're going to use to create the payment intent, because with the product ID, we're going to know the price of the product, so we know how much we're going to charge the user. Now, this data here is to send the product to the user, but this data isn't going to be used on the Stripe end. Like, we're not sending this data to the Stripe server. This we're not going to in this tutorial, but what we would do with it is we might say, for example, store this data in a database with like an order number, and then associate the order number with that customer's payment intent somehow. And then later on, when we receive confirmation that the customer confirmed the payment from Stripe, then we could access that customer's like shipping information in a database or something and send the product. But in this tutorial, we're not doing the database for this at all. We're only going to focus on the payment. So what we're going to need for the code that we're actually going to write is this request product ID, which is the first field in this JSON object, and it's also the first field in our Go struct. So now we can start writing the code to create the payment intent. And to create the payment intent, we actually need to import some packages from Stripe. So Stripe actually has tools written in Go that integrate with Go code. So if you go to your web browser and you type in Go Stripe, you see this Go library for Stripe API. So you go to this GitHub page and you scroll all the way down to the documentation, and it tells you how to install it here, installation. So essentially what we're going to need to do, we don't need to do this part because Goland already did this part for us. So let's just try to first write the code for creating a payment intent and then doing the imports after that. So let's see if we can do that. So to write the code to create a payment intent, we first need to create the parameters that we need to pass to the Stripe API to create the intent. So we're going to say params equals, and then the and symbol, stripe.payment intent params. And we're going to do it like that. So we're going to go back to Chrome, and here we're going to use this command here to install the packages. And let's go back, and inside of our directory, our project directory, we can paste this command and paste it in and then press enter. So then it added those. So now we should be able to go here and import them. Actually, it's saying it's indexing the dependencies. Okay, so it added that for us then. So now if we go back down here, this is working fine now. Okay, So this here comes from the Stripe library, and so does this payment intent params. So this is basically a struct as well. So we just created a struct, right? So to request for Stripe to create the payment intent object for us, we need to give them these parameters here, and they're not all required. Only some of them are required. So let's fill those in to create the params. So these are the params we're going to send to the Stripe API, and then based on these params, the Stripe API is going to send us the payment intent object. So the first param is going to be the amount, and the amount is going to need to use Stripe's type called int64 and an amount. And the way that we're going to do this amount is we're going to create our own function called calculate order amount. And it's going to take in the request.product ID. Now let me explain what we're doing here. So we need to give a value to amount to give to the Stripe server. And I explained to you, we have to send this information to the Stripe server so they can send us the payment intent object back, the same one that I explained when I went over it with the Blackboard. Now, Stripe has its own int64 type. And whatever we return from our function, we need to convert it to Stripe's int64 type. And remember earlier I explained to you how to convert one type into another type. Remember I told you, for example, we can do string and then put an int in there, and it would convert this int into a string, which would end up being looking like this. So we're doing the same thing here with Stripe's own int64 type. We're converting the return value of this function we're going to create into Stripe's own int64 type. So we need to create this calculate order amount function. So we can go down here under our health function, and we'll create another function called calculate order amount, and it's going to take in a string, which is the product ID. And remember, this product ID is coming from the request. Remember, we're asking for product ID in the request. And this is how we're going to know how much to charge the person, because we only have a select number of products. And based on the product ID, we know the price of the product. And I'll show you what I mean by that soon. So we're going to need to take the product ID into this function that we create. And our function is going to need to return a normal int64. So Go has a type called int64 as well. And you don't have to know what 64 means. Just think of it as an integer. It's just a different size integer. Just think of it as an integer. And we're going to return int64 from our calculate order amount function. And our calculate order amount function is going to be simple. It's just going to return a price depending on what the product is. And we'll just go ahead and use a switch statement here. So switch statement is basically just a conditional statement. So we'll do switch product ID, and then we'll do brackets, and we'll say case. And if the product ID is forever pants, we'll return the price for forever pants. And we'll say they're 26,000, but this is because we're doing the money in cents. So this is actually just $260. And then we'll do case forever shirt, and the forever shirt is going to cost $155. And we'll do case forever shorts, and the shorts will be $300. And if it's none of those, we'll just return 0. And it actually should never be none of them, but we're not doing any validation on the input from the person sending the request, so it's possible. So we'll just return 0. So this is our calculate order amount function. And here, to get the amount for this struct that we're going to use to send the request to the Stripe API, we're going to call the calculate order amount function with the product ID, which is going to be the name of the product. So the product ID is either going to be forever pants, forever shirt, or forever shorts. And it's going to return the corresponding price. And that price is going to get converted to Stripe's int64 instead of Go's int64. So that's going to be the amount. And the next field that we need to fill in, and let me just clarify here, this is the same thing as if we were to do if product ID equals forever pants, return this. If product ID equals forever shirt, return this. But switch is just like a cleaner way to do it. Like we can just do switch and product ID. If product ID is this one, then return this. If product ID is this one, then return this. If product ID is this one, then return this. So it's the same thing. It's like a conditional thing. Anyways, so after we add the amount to that struct, we need to add another field. And that field is going to be currency. And we're just going to default this one. So it's going to be a Stripe string. And then we're going to just convert into a string stripe.currency USD. Now, this currency USD is provided by Stripe. And the type is currency. Stripe's currency type. Stripe has its own currency type. So that's why we need to convert it into a regular string here. And then we're converting the regular string into Stripe's string. Now, I know that's kind of confusing, but you don't really need to know the details about that. Actually, I think Stripe should make it so that you can convert their currency type into their string type, but apparently you can't. So I tried it this way, and I'm actually not able to convert their currency type into their own string type. So it says cannot use Stripe currency as type string. So yeah, we need to convert it to a string first and then convert it into their string. But anyways, that's currency. So after we fill in currency, we need to fill in this automatic payment methods. And this one's going to be Stripe.payment intent automatic payment method params. Now I know this is starting to look really confusing, but again, this is only a struct. So this is just another struct provided by Stripe. It just has a really long name. So Stripe wants us to provide an automatic payment methods field for this payment intent param struct. So like each of these are parameters that we're going to need to give the Stripe API to create a payment intent, right? So that's why this struct is called payment intent params. This one here, it's called payment intent params because it's the parameters that we need to ask Stripe to create a payment intent. So the parameter 1 is amount, parameter 2 is currency, and the other parameter we need is this automatic payment methods. But this automatic payment methods, the value for this parameter is another struct. And this struct is called payment intent automatic payment methods params, which is a long name, but all they want is a bool here. And it says when enabled, this payment intent will accept payment methods that you have enabled in the dashboard and are compatible with this payment's other parameters. So basically in the dashboard that I showed you earlier where we got those keys from, if we enable this, we can use the payment methods that we have enabled on the dashboard. So we're just going to go ahead and pass a bool of true to this long name here. So we'll set enabled, the field enabled equal to Stripe bool true. And you'll notice if we hover over this struct, the field that it expects is enabled and it's a bool. So we're filling in the field and we're giving it a value of a bool, but it has to be converted to a Stripe type. But we're giving it the value of true. So that's all of the payment intent params we need to use. I know there's a bunch of them here, but we only need to use these three, thank God. So now we have this payment intent params object that we can send to the Stripe server and request that they create the payment intent. So this thing that we created just now that we filled in, it's going to be assigned to this variable here params. And we're going to pass this params variable to the Stripe server. And I know this is getting a bit tedious, but just bear with me. I hope that I'm able to help you to understand what we're doing here. So once we've created the params for the payment intent, we can actually send a request to Stripe to create the payment intent. So we'll say payment intent, and error, because it potentially returns an error, equals payment intent dot new. And this payment intent here also comes from Stripe. It's a package from Stripe. It's just that Golang auto imported it. So if we go to the top up here, we see that we have this package payment intent from Stripe Go. So we're calling this payment intent function called new. So this is how you create a payment intent. You call this new functions. You see function new, and the params it expects is a Stripe.payment intent params. And that's what we created here. So this can go in here. So we'll do params. And if you check here, you can see that it expects a pointer, and we're getting it, and we're creating a pointer here. This is a pointer we're creating. But remember, you don't need to know about pointers yet. That's something that you'll learn later on. So yeah, we're passing in this object here with these values that we've created here. So we're passing that into this new function. And since it potentially returns an error, we have to handle the error if one exists. So if error not equals nil, in this case, we'll return an internal server error, the same as this one. From when we decode it to JSON, we're going to return that if the error is not nil. So we're doing the exact same thing here. If creating the payment intent with the Stripe server returns an error to us, we're going to return an error to the front end with the error as a string and an internal server error status. But if we're successful, we'll have the payment intent, because look, we're assigning payment intent to this variable payment intent, right? So that means that we'll have the payment intent if we don't get an error here. So down here, we'll have the payment intent. And remember when I showed you in the Blackboard, the payment intent is going to have a customer key, like a secret assigned to it. And it's going to be called client secret. This is the customer key that I was explaining to you in the Blackboard, using the Blackboard. So remember, this client secret is going to get sent back to the front end. And then when the customer confirms the order, the front end is going to send this client secret and the order confirmation to the Stripe's payment confirm API. And that's going to confirm the payment for the customer. So we need to send this client secret back to the front end. But first, let's go ahead and test out what we have so far. So we'll just print this for now. So print line. Now remember, this new function is actually going to call Stripe's API. It's going to call Stripe's server. So it looks like it's just a function in our code that just triggers some code in this package, right? But this code that gets triggered actually sends a request to Stripe's API to create this payment intent. And Stripe's API returns the payment intent to us here. They either return the error or the payment intent. And when we get the payment intent, it's actually from the Stripe server. And we're going to print the client secret that we got from the Stripe server. And this is still, all of this code is still inside of our handle create payment intent endpoint. So let's test this out. Let's go ahead and test it out. And we have to make sure when we give the product ID, we have to use one of these. So yeah, let's run our server, go run server.go, and let's go open Postman, and let's change our product ID here to one of the ones we actually have a price for, and let's send this. And actually we got an internal server error, and that's because we didn't provide, so you can see, let me try and make this larger. So you can see the response that we got from the API. And our API is actually just returning the response that we got from Stripe when we tried to send the request. So Stripe tells us you did not provide an API key. You need to provide your API key in the authorization header. So I forgot to actually show you that we need to do this. So when we're calling Stripe's API from our server, when we're calling Stripe server from our server, we need to have a key, an API key to access their API. So that's why we got the error here. We didn't provide the key. So you need to go to your Stripe dashboard. So open the browser and do Stripe dashboard and Stripe login and sign into your Stripe account. And once you're signed into your Stripe account on your dashboard, you're going to see this secret key here. Now this secret key is the key that you need, and it's just a test key, so don't worry. But yeah, this one you want to copy. So you're going to copy the secret key, and then you're going to go back to your Go code, and let's minimize that. And we're going to go back up to our main function area. Now in a real world situation, you'd never store your key, any type of secret key or any type of secret in your code, in your actual code. This is like a huge security vulnerability, but this is a test key and this is a tutorial. So yeah, I just need to make that clear so you guys don't think that this is a common practice or something you should do in a real world scenario. In a real world scenario, this is not how you should handle your secrets. So I'm just going to do stripe.key. So this is a variable from Stripe, and we can set it equal to the key that we just copied. So this Stripe key, if you hover over it, it says key is a Stripe API key used globally in the binding. So if we assign our key to this variable that comes from Stripe, Stripe's going to be able to use this key when it makes calls to the API. So when it makes a call to the API down here in this new function, it's going to make a call to the API, and it's going to use the key from that variable that we just gave it. But I have to say this again, this is not something that you would ever do in a production application. You'd never just store the secret in the code like this, like right in the open. This is just a test key, and this is just for purposes of teaching you how to do this and teaching you the Go programming language. But this isn't a practice that you should get in the habit of doing. But of course, I don't have time to teach you how to actually handle secrets in an application in this tutorial because it's not the focus of this tutorial. But just please remember that this is not, don't get in the habit of doing this. But anyway, so this is our API key. We're assigning it to Stripe's key variable, and Stripe's going to use it when it calls its own API in this new function. In this new function here, where we're asking Stripe to create the payment intent and send it back to us. So we can go down here, Control C, and let's clear that, and go run server.go again. And now let's go back to Postman and let's send it again. Now this time you see we got a 200 status okay. So that means if we go back to our code, our server here, you see that our customer's secret, the client secret, gets printed to the screen. And again, you're not going to want to print the secret to the screen. You never want to print secrets to the terminal, but we're doing this for testing purposes. And of course, this isn't a real client secret. This is a test client secret. So anyways, just keep those things in mind. So we've got the application working up until this point. So now we just need to send this client secret back to the front end. So the front end, whenever the customer confirms the order, can actually use this client secret when sending the confirmation of the payment to the Stripe server. So to do that, we're going to create another struct, and we're going to call it response. So the same way we created this struct for the request up here, we're going to create another one for the response that we're sending back to the front end, because we're going to send it back to them in JSON, basically. The same way they sent the request body to us. So we'll just call this response, and it's going to have client secret, and it's going to be a string, and its JSON equivalent is going to be client, and we'll do secret. We're not going to do snake case this time because the front end is going to use camel case. So we're going to send it like this. So now we have this structure, right, that it only has one field, which is client secret, but it's empty right now. So this response is empty. So we need to take this response dot client secret, and we need to assign the client secret a value of this client secret here. So from the payment intent that we got here, we can get the client secret. So we'll do payment intent dot client secret. So now our response has the client secret in this field here. So now we can send this response back to the caller of our API endpoint. So now instead of decoding the JSON like we did before, so before, remember, we were decoding the JSON because from the request, we're sending JSON. This is JSON. See here, JSON. So we're sending JSON to the server. So we need to decode that into Go code, right? So we needed to decode it into Go code. But now we're doing the reverse. We need to convert Go code. This struct here is Go code, right? We need to convert this struct into JSON. So now we need to encode. So we need to use JSON.new encoder, and we need to encode it into what we call a buffer. So we'll just say var buff is bytes.buffer. And you don't need to know details about this bytes.buffer here. So just know that we need to send it back in bytes. And I explained to you some stuff about bytes when we went over the byte slice. So into this buffer, we want to encode our response. So this response here, so this response, we want to encode it using this encoder into this buffer. And remember, this returns an error. So we want to do error equals, and then do if error not equal nil, and then we need to handle the error. And remember, I forgot, I told you we can't declare a variable again, remember? So we have to not use that since we already declared this error up here somewhere, here. So we already declared the variable. So now we can just use error equals here. And then if error not equal nil, we're going to do the exact same thing that we did with when we were decoding, which is the same thing that we did here as well when we sent a request to the Stripe API to get the payment intent object. We're going to return the same error in this case, an internal server error. So if we can't encode this response, then we're going to return this error to the person sending the request. But if we can, after it's encoded, we're going to send it back to the person that sent the request to this endpoint. And we're going to do that using our writer. Remember the writer that we used before, it's at the top of this function, the writer here. We're going to do writer.header.set, and we're just going to do content type application JSON. Now, all this is doing is it's adding a header to the response, and it's essentially like a tag that we're adding to the response that labels this response with content type JSON, because we're sending back a JSON object to the caller. So we're sending a JSON object similar to this one, but ours is only going to have one field, which is the client secret, but we're still sending a JSON object back. So here we're just essentially adding like a tag to the response saying that it's a JSON object. And then after we do that, we need to actually do something that's going to look super complicated, but I'm going to explain to you what it's doing. So we're going to do io.copy, and we're going to pass in our writer and that buff that we created. Now, if I hover over this copy, so IO is another package from Go Standard Library. So if you scroll to the top, you see that it automatically got imported. Now, if I hover over this copy, you see that copy copies from source to destination until end of file. EOF means end of file is reached on source or an error occurs. Now, end of file just means exactly what it says, end of file. So imagine that JSON object is just a stream of data and we're streaming it into the writer. That's all this io.copy is doing. So it says copy copies from source to destination until end of file. So once that stream reaches the end, there's nothing left to stream into writer, right? So at that point, the entire buffer has been written to writer. And that's essentially what this io.copy is doing in simple terms. So we'll go ahead and it's going to return, it potentially returns an error. So we have to do error equals, and then if, actually it returns something else too, but we're just going to ignore it. So we'll do if error not equals nil. In that case, we're not going to be able to return anything because we'd already be done with the writer at that point. And the writer is how we return things to the caller, the person calling our endpoint. So at that point, we would just print line if there's an error. We'll just print the error. And I forgot to add the package. And that is everything for this endpoint. That is the code for this create payment intent endpoint. So at this point, you can go to project and let me close that and format your server.go file. And now we can go ahead and test this out. So here we're sending the request to the Stripe server to create the payment intent, and it's sending us back the payment intent object in this payment intent variable here. And then we're printing it here, but we don't need to print it anymore. That was just for testing. Then we're creating a response struct. This is the structure of the data that we're going to return, and I'll show you what that is in a second. So this is what gets returned to the person calling our endpoint. This is what the structure is. It's going to have a field client secret with a value. Then we're setting this client secret field in this empty struct to the client secret, which is inside of the payment intent object here, the one that we got from the Stripe API. And then we're creating this empty buffer, and then we're encoding our response, the one that we created up here, into a JSON string essentially. And then we're adding this header here, which is essentially like just a tag saying that this response is going to be of type application JSON, which is JSON. And then we're copying from that buffer, that JSON string, into the writer, and the writer is the response writer. So this is what the caller of the API is going to be able to read from. So let's test it out. So let's stop running our server and then do go run server.go, and let's go to Postman. And the moment of truth, let's send this request. And as you can see, what we get back is this JSON structure that has a field client secret, the same as I showed you in the backend code, and it contains the client secret. So we've successfully implemented our backend, and now all that's left to do is connect it to the front end. So yeah, this is the response body. So this is the body that we send to the front end. And the front end is going to take this client secret, and when the customer confirms the payment, the front end is going to send this client secret in a call to before we connect some unexpected we created called calculate order amount. We can see for Everpants cost rate a payment intention or anything like that, because that's going to be updated on Stripe or populated on Stripe once the front end sends the confirmation of the payment to use code. So let's go for directory. So let's move back one folder. So you should this page once you've changed that to beginner's front end folder, and let's clear. And then you can just select and open up your terminal again and the product page at localhost 3000/product. And from here, you should be able to select a product. So whatever product you select, that's going to be the price that shows up for the payment on your Stripe dashboard. So for example, I'll select this shirt, put in whatever you want here, because you should simply be able, that's going to be the price that shows up for the payment on your Stripe dashboard. So for example, I'll select this shirt, I'll just select buy now. And from here, you should simply be able to input some fake data. So I'll just put in like John Doe, but you can actually put in whatever you want here, because remember, we're not going to add the functionality to actually store the shipping address and stuff like that in the database for this tutorial. So although this will be sent in the payload to our backend after so already sent the request future date. So we can just do email@gmail.com, and you can select this, save your info for secure one-click checkout with link or whatever, but you don't need to do that. So you can just hit pay now. And when you hit pay now, our front end is going to send a request to the Stripe server using the customer, like the client secret for that payment intent that we originally initiated when we picked the product that we wanted to buy. And it's going to confirm the payment, and that should show up on our dashboard. So let's hit pay now. And you see we get directed to this payment successful page, or payment has been processed successfully. You'll see the payment, the customer, or Stripe's agent now. But once I add some dummy data here for this tutorial. called source. So we change directory. Maybe let's go to Goland and we can stop running our server for now. And let's just select project here. Actually, we can just hit file up here and then just select open. And then here, you should be able to open this Go for begin. It has to be this. And now all we need to do is go back to our terminal and let's just change directory back one directory. Goland IDE again. And you can leave this page once you've changed that to your publishable key. And then you can just select terminal and we need to run the server again. So we need to have IDE again. And you can leave this page once you've changed that to beginner's front end folder. And let's clear. And then open your Goland IDE again. And you can leave this page once you've changed that to your publishable key. And then you can just select terminal and we need to run again an product page at localhost 3000/product. And from here, you should be able to select a product. So whatever product you select, that's going to be the price that shows up for the payment on your Stripe dashboard. So for example, I'll select this shirt. I'll just select buy now. And from here, you should simply be going to our back end. We're not inputting that dummy data at the moment. So just go ahead and put in some dummy data here. And then you can just hit next. And at that point, after you hit next after inputting that dummy data, and we end up on this enter your credit card information page, our back on our dashboard. So it's like we can the test. You see, this is one for brand you want to use. There's actually multiple different ones that we can use. It's similar to these VC in 2024. And originally we get directed to this page enough if we PY here off as in is communicating with the Stripe servers, and we've successfully implemented this product payments shipping thing too much and check which customers actually purchased a particular product. And actually, I recommend that you try and build this out more to make it more functional, like more functional. And it runs on. It doesn't exist as to production without. We don't have TLS on this site. Type in to ensure that. And that information package sort of, even though it's local environment. As a final note, if I'm like, because I doubt you finished a 5-hour plus video without actually getting something of value from it. So yeah, in that case, you should leave a like so other people can get exposed to this type of content as well. Anyways, congratulations on completing this tutorial, and I'll see you in the next one.
Hey, do you think they'll shrink us like these new M&M's minis?
You say the strangest things.
It does seem kind of.
So that is going to do it. Yep, that's it. This is the end of the. This is the end of the Go YouTube tutorial series journey. Next week. Yeah, there we go. Next week, let me have a look at my notes again, see what thing we start off with on first. I think we're going to start with the tour of Go. So we're just going to get straight into yeah, just like doing some practical stuff now because we watched plenty of stuff on that. We don't need to do any more. That'll be it. So I'm going to sign off. That's it. Thanks for coming. Thanks for watching. Thanks for sort of learning along. Hope you picked up on some good stuff. Thanks to the tutorial maker again. I'm going to feel really thingy because what was his name?
Learn the fundamentals of Go.
Thank you to Catan Coding and FreeCodeCamp for providing that great resource. It's probably a little bit too beginner for me, and I didn't get into quite enough of the things that I wanted to sort of like learn. So we'll just pick up. It gave me some basic syntax. I've had a little watch of code to understand enough of the basics. So next time we're just going to start smashing out. Yeah, the actual like what do you call it? Practical stuff. So if you're coming back from the future, thanks for coming back. Hope you enjoyed it. If you've been here on the live stream, then thanks for joining in. Hope you have a good night, good week.